Welcome, curious minds and sleepy thinkers. You've found a soft place to land where the questions are big and the pace is slow enough not to jolt you out of your pillow cocoon. As the world outside settles into its gentle slumber and the stars begin to emerge in their silent dance, we too shall drift into a realm of quiet contemplation. Tonight, we're going to tiptoe into one of the most mysterious and inspiring narratives of our shared human journey. The story of our relentless gaze, skyward the gentle stretch of our understanding towards the infinite, and the whispers of other worlds that call to us from beyond our earthly home. But don't worry, we'll take it slow. This isn't a race through facts or a hurried march through timelines. It's more like floating through a galaxy of ideas with a cup of chamomile tea, allowing each thought to unfurl gently like a blossom opening to the dawn. We won't chase answers with frantic energy, but rather invite them in, letting them settle softly into the quiet spaces of our minds. We will explore the grand ambitions and the tender triumphs, the quiet perseverance and the breathtaking beauty of our collective journey into the cosmos, all wrapped in a blanket of calm. Imagine for a moment that our Earth is but a tiny luminous pearl suspended in a vast, dark ocean. For eons, we its inhabitants have looked up at the shimmering surface of that ocean, marveling at the distant lights that twinkle like scattered diamonds. There has always been an innate pull, a deep silent question echoing within us. What lies beyond the pearl? What secrets do those distant lights hold? This ancient curiosity, softer than a sigh but stronger than any storm has been, the quiet engine behind our spacefaring dreams. It is not merely a desire to conquer, but a profound need to understand, to connect, to simply know. Our journey tonight will reflect this very essence. We will not dwell on the thunderous roar of rockets, but on the silent poetry of their ascent, the gentle arc they trace against the canvas of night. We will speak not of the cold mechanics of machinery, but of the ingenious human spirit that breathes life into metal and wire, sending our proxies, our silent messengers across unimaginable distances. Each probe, each orbiter, each tiny rover is not just a collection of circuits and sensors. It is a whispered thought, a collective yearning sent forth from our small pearl into the grand cosmic ocean. Think of the night sky not as an empty void, but as a vast unfolding storybook, each star a word, each galaxy a chapter. And as we turn the pages together, we'll discover how different hands from different corners of our Earth have contributed to this magnificent tale. Some chapters are tales of unexpected success, like a delicate seedling pushing through unexpected soil. Others are stories of quiet persistence, where obstacles are not met with shouts of defiance, but with patient, steady resolve like a river carving its way through stone, not by force, but by gentle, unending flow. We will learn of the ingenious ways we have learned to listen to the whispers of distant planets, to interpret the shimmering veils of their atmospheres, and to discern the ancient scars etched upon their surfaces. It is a dance between the known and the unknown, a delicate balance between what our instruments can reveal and what our hearts can only imagine. And in this dance there is profound beauty, a deep peace that comes from acknowledging the vastness beyond our grasp and the endless possibility that unfurls before us. So let your thoughts quiet, let your breath deepen, and allow yourself to float gently on the currents of these stories. There is no need to grasp or hold tight. Just listen and let the wonder seep in, like the first light of dawn painting the sleeping landscape. This is a journey of the mind designed to soothe and inspire, a quiet adventure into the infinite. We begin, as all good journeys do, by simply being present, by opening ourselves to the quiet magic that surrounds us both within and without. Our exploration will be a slow, deliberate walk through the garden of human endeavor in space. Each bloom we encounter will be a different mission, a different triumph, a different lesson. We won't rush past them, but pause to admire their unique petals, their subtle fragrances, the quiet strength that allowed them to unfurl against the backdrop of the cosmos. Some of these blossoms are vibrant and well-known, bathed in the gentle glow of public awareness. Others are more secluded, perhaps a little overgrown with the passage of time, but no less beautiful, no less significant in the grand tapestry. Consider the notion of scale, not in terms of daunting numbers, but as a poetic invitation to expand our inner horizons. The distances we speak of are vast, certainly, but imagine them instead as quiet stretches of time moments suspended between one breath and the next, allowing a probe to drift patient and resolute towards its distant embrace. When we speak of millions of kilometers, let it feel not like an insurmountable chasm, but like the gentle, endless flow of a river carrying our dreams ever onward. And in this gentle flow, we find companionship. We are not alone in our curiosity. Across continents, under different skies, countless individuals have gazed upward with the same quiet longing, the same profound sense of wonder. Each engineer, each scientist, each dreamer who has contributed to these missions is a thread in this magnificent tapestry, weaving their unique skills and insights into a design far grander than any single mind could conceive. It is a testament to our shared humanity, our collective yearning to understand the universe that cradles us. We will touch upon the technological marvels, but always with an eye towards the simple, elegant ideas that underpin them. A complex navigation system becomes a celestial cartographer, patiently mapping its way. A sturdy spacecraft becomes a resilient seed, capable of sprouting new knowledge in the harshest of environments. These are not mere machines. They are extensions of our senses, delicate fingertips reaching out to touch the untouchable, to see the unseen. And as we explore these stories, let us not shy away from the moments of mystery, the places where our understanding gently fades into the unknown. For it is at these very edges of our knowledge that the deepest sense of wonder often resides. When science reaches its current limit and the equations fall silent, we are left with a beautiful open space for contemplation. It is an invitation to simply wonder, to embrace the magnificent we don't know, and to find peace in the vastness of what remains to be discovered. This is not a failure, but a profound privilege, to stand at the precipice of infinity and simply breathe. So close your eyes if you wish, or let your gaze soften as you listen. Allow the gentle rhythm of these tales to carry you. We embark now on a quiet voyage, not of physical travel, but of mental exploration, a journey inward as we explore the outward reaches of our universe. Each mission, each discovery, each brave step taken by humanity into the cosmic ocean is a testament to our enduring spirit, a soft, persistent hum in the grand symphony of existence. Let this hum resonate within you, a lullaby of science and wonder as you drift towards a peaceful night. This is our shared story told in hushed tones under the vast and benevolent gaze of the stars. India's quiet triumph in space began with a mission that felt less like a thunderous roar and more like a gentle, determined whisper. In 2014, the Indian Space Research Organization ISRO achieved an amazing feat with its Mars orbiter mission, affectionately known as Mangalyaan. Imagine for a moment sending a tiny inquisitive hummingbird across a vast ocean to a distant island and having it land softly on its first attempt. That's the essence of Mangalyaan's success. They successfully inserted a probe into Mars's orbit on the very first try, and for a relatively minuscule $66 million. This quiet efficiency set a new tone, a testament to the idea that immense ambition doesn't always demand immense resources. It made ISRO the first space agency in the world to have a successful Mars mission on its inaugural attempt, and the first Asian agency to reach the red planet. This alone is a story of profound dedication and meticulous planning, a testament to a nation quietly reaching for the stars with grace and ingenuity. The journey to the red planet for Mangalyaan wasn't a direct, powerful thrust, like a sprinter bursting from the blocks. Instead, it was a nuanced, patient climb, much like a seasoned mountaineer gradually ascending a peak, conserving energy, and finding the most efficient path. Launched from India in 2013, aboard an ISRO rocket, This particular launch vehicle was primarily designed to insert satellites into orbit around Earth, not to send probes directly to distant planets. It didn't possess the raw brute force the colossal thrust needed to propel Mangalyaan straight to Mars. So the probe had to employ a clever strategy, a dance of gravitational assists around its home planet. Picture a child on a swing, slowly building momentum with each gentle push, gaining height with every arc. Mangalyaan did something similar around Earth. It used some of its own precious fuel, not in one mighty burst, but gradually over several carefully orchestrated orbits to leave Earth's gravitational embrace. Each pass around our blue marble added a little more velocity, stretching its orbit further and further, like an elastic band slowly being pulled taut. This patient accumulation of speed allowed it to eventually break free a quiet departure, almost unnoticed in its deliberate precision. It was a lesson in gentle persistence, demonstrating that sometimes the longest journeys are begun with a series of small measured steps, each one building upon the last, until the vastness of space finally opens before you. Upon arriving at Mars, Mangalyaan settled into a highly elliptical orbit, a shape that was quite different from what we might typically imagine for a planetary explorer. Instead of a tight circular embrace around the Martian surface, Mangalyaan's path was more like a long drawn-out oval, a cosmic egg whose ends stretched far into the blackness. At its furthest point, this intrepid probe would be almost 880,000 kilometers from Mars, a distant observer. Yet at its closest approach, it would swoop down, skimming the Martian surface at a mere 420 kilometers above its ruddy plains. This unique path was not a random choice, but a deliberate design, a reflection of the mission's particular goals. This highly elliptical dance was notably different from NASA's Mars Reconnaissance Orbiter, for example, which maintains a much closer, more circular orbit, hugging the Martian surface to capture images at extremely high resolution. Think of it as the difference between an artist standing back to admire the entire canvas from afar and another leaning in close to meticulously paint the finest details. Mangalyaan, with its sweeping grand arcs, was designed to see the whole, to grasp the larger picture. Its orbit was a wide, encompassing gaze, allowing it to capture global views, seeing Mars as a complete, vibrant entity, rather than just isolated fragments. It truly felt like more of a technological demonstration, a proud declaration of capability, a gentle nod to the scientific community that India had arrived ready to contribute its unique perspective to the grand cosmic tapestry. Glimpses from this distant vantage point offered a truly unique perspective of the red planet. Because of its highly elliptical orbit, Mangalyaan could sweep back and observe the whole of Mars in one go. Imagine yourself for a moment floating far above a magnificent painted globe. From that distance, you can take in the entire panorama, the vast interplay of colors and textures, the dramatic sweep of continents and oceans. This global view was reminiscent of the old NASA Viking missions, which also provided breathtaking, encompassing images of Mars. There's a particular beauty in seeing an entire world laid out before you, not as a series of stitched-together fragments, but as a single coherent masterpiece. And indeed, from this distance, Mars truly is a beautiful planet. Mangalyaan's camera, simpler perhaps than some of its more specialized counterparts, offered true color images. This meant that the raw pictures, unfiltered and unenhanced, showed Mars as you would see it with your own eyes. If you were gently orbiting in space, the planet revealed itself in its authentic hues, the brilliant white caps of carbon dioxide and water ice shimmering at its poles like ancient frozen crowns. Across its vast surface, a varied mosaic of reddish rock, soft sediments, and dark dust patches provided an interesting, subtle contrast. It was a palette of earthy tones, streaked with the stark brilliance of ice, a silent painting by the forces of geology and time. The face of Mars, as seen through Mangalyaan's eyes, was a testament to the planet's dramatic past and its enduring geological narrative. Craters of various sizes, like ancient scars from cosmic collisions, span the planet, some small and delicate, others vast and imposing, whispering tales of bombardments from eons ago. And amidst these ubiquitous impact marks, some of Mars's most intriguing features were also beautifully visible. Its long dormant shield volcanoes, gently sloped giants, stood as silent monuments to an era of fiery upheaval, their massive forms softened by time and dust. Huge valley structures carved by forces, perhaps long vanished, snaked across the landscape, reminiscent of colossal rivers that once flowed, leaving behind their enduring imprints. It was a landscape of quiet grandeur, a silent stage upon which countless geological dramas had played out, now preserved for our distant gaze. Beyond the static features, Mangalyaan also captured the dynamic breath of Mars, its atmospheric phenomena. What was also visible, even from this considerable distance, were some of Mars's famous giant dust storms. Imagine seeing a vast swirling veil of ochre stretching across thousands of kilometers of the northern hemisphere like a colossal restless spirit. In one particular image, such a dust storm spanned an immense expanse, a testament to the powerful unseen currents that sweep across the Martian landscape. These colossal storms are not mere atmospheric disturbances. They are events that can last for weeks, even months, almost completely blocking sunlight from reaching the surface under their densest parts. For solar-powered rovers like Opportunity and Spirit, storms like these caused significant issues enveloping them in a prolonged twilight that drained their vital energy, a slow, gentle dimming of their light. But Mars's atmospheric canvas held more delicate brushstrokes than just the grand sweeping dust storms. Smaller, more localized storms could also be glimpsed in some of the other global views, captured by Mangalyaan like fleeting disturbances in an otherwise vast calm. And then there were the orographic clouds often seen gracefully draped over the peaks of Mars's volcanoes. Yes, these are indeed water-ice clouds shimmering faintly in the thin Martian air. While the atmosphere of Mars is considerably thinner than on Earth, and most of its water has long since slipped away into the vastness of space, there still remains a small lingering amount of water vapor. This delicate presence manifests in these ethereal clouds, forming when air, in its gentle journey across the landscape, is forced higher as it encounters elevated terrain, cooling, and allowing its meager moisture to condense into visible form. In one particularly striking image, Mangalyaan captured 3 smaller volcanoes, each crowned with these delicate orographic clouds. Over Elysium Mons, the central volcano in this trio, the clouds formed like soft, swirling halos. It's a quiet testament to the subtle interplay of geology and meteorology on a distant world, a reminder that even in seemingly harsh environments, beauty and intricate processes continue to unfold. These clouds are fleeting, ephemeral things, a soft breath in the vastness of the Martian sky, yet they offer a tangible link to the planet's remaining water, a gentle whisper of the life-giving element that once may have flowed abundantly across its ancient surface. During a closer approach over Elysium, Mons Mangalyaan offered us an even more intimate glimpse of Mars's intricate surface. The orographic clouds, though still visible, appeared less prominent, allowing other features to emerge with greater clarity. More apparent were the trenches that encircled the volcano, like deep ancient furrows etched into the Martian soil. These are called fossa trenches, and their formation speaks of the slow, powerful forces at work beneath the planet's crust. They are thought to have formed by the stretching of the plate they reside on, often caused on Mars by the immense sheer weight of the nearby volcanoes. Imagine the colossal burden of these sleeping giants pressing down on the crust, causing it to gently pull apart, creating these elongated depressions. As more material gently falls into them over eons, these fossa widen, deepening their silent embrace. Think of them not as abrupt chasms, but more like a series of connected sinkholes on Earth, slowly expanding. However, the mechanism on Mars is different. On Earth, sinkholes often occur when material is eroded from under the surface, causing the ground above to gradually collapse. On Mars, the fossa are primarily due to a fault under the surface, a deep-seated crack that can extend sometimes up to 5 kilometers into the planet's crust. These are not sudden dramatic collapses, but rather slow, persistent geological features, silent witnesses to the deep-seated forces that continue to shape the Martian landscape, a gentle reminder of the planet's inner life. A closer, more contemplative examination of one of these fossa revealed something truly unexpected and beautiful, a fleeting moment captured inadvertently by Mangalyaan. Right in the middle of this image, our gentle guide revealed what appeared to be a tall, wavy structure, like a slender dancing ribbon caught in the wind. This was no static geological feature. Mangalyaan had inadvertently captured a giant dust devil, a swirling column of Martian air and dust, its shadowy form stretching out for several kilometers across the landscape. Once you notice that one, your eyes now attuned to its subtle presence will realize there are actually a few more in the image, each marked by a long winding shadow, like a painter's delicate brushstroke trailing across the canvas. These dust devils are nature's quiet tornadoes, ephemeral and graceful, born from the subtle dance of sunlight warming the Martian surface and creating rising columns of air. They are not as violent as Earth's tornadoes, but more like a continuous gentle twirl, silently sweeping dust across the plains, leaving their ghostly tracks behind. They are a beautiful testament to the unseen energies at play on Mars, a reminder that even in its thin atmosphere, there is movement, there is life, albeit a life expressed in the gentle swirls of dust and shadow. Our gaze then drifts to another majestic Martian landmark, Olympus Mons, the tallest volcano in the entire solar system. Even from a great distance, its sheer scale is humbling. Imagine a mountain so vast that from its base to its peak, it stands 3 times taller than Earth's Mount Everest, and its base spans a breathtaking 600 kilometers wide. As a result of its colossal dimensions, Olympus Mons is easily visible and recognizable, even from Mangalyaan's high altitude, a silent sentinel dominating the Martian horizon. From this sweeping view, one can also easily discern where rivers of ancient lava, long since solidified, have flowed down onto the plains surrounding the volcano, like the gentle wide fingers of a colossal hand, leaving an indelible mark on the landscape. These are quiet scars, telling tales of fiery eruptions from an age long past, now resting in profound tranquility. Looking a bit further across this vast Martian panorama, our eyes are drawn to 3 more big shield volcanoes, their forms equally grand, with a few smaller ones nestled to the north, like younger siblings clustered around their elders. And then your attention might gently shift to this rather peculiar patch, a region that looks almost like a labyrinth, aptly called Noctis labyrinthus. This isn't a structure built by intelligent hands, but a feature carved by the deep internal stirrings of Mars itself. In a similar vein to the Elysium Fossa Noctis, Labyrinth is thought to have formed because of the huge volcanoes to the northwest. But this time, the mechanism might be even more profound. Perhaps it was due to collapsed magma chambers deep under the surface, the very heart of the volcanoes gently subsiding, creating these intricate maze-like patterns on the crust above. Research into this mysterious region is still ongoing, a quiet pursuit of understanding the planet's hidden depths. Connected to the enigmatic Noctis labyrinth is another of Mars's most famous scars, the colossal Valles Marineris. This isn't merely a valley. It is a grand, sweeping chasm that stretches for an astounding 4,000 kilometers across the Martian landscape, a silent testament to the planet's immense geological power. What is truly captivating about the images captured by Mangalyaan, and what brings a gentle sense of connection, is that just like the historic Viking missions, faint water ice fog can be seen gently filling this chasm. Imagine a soft, ethereal mist clinging to the deep contours of this ancient scar, a fleeting whisper of water in a world now largely dry. From this colossal valley, channels appear to flow out to the east, leading into what are called chaos regions. These regions, similar but smaller than Noctis Labyrinth, are areas of jumbled terrain as if the ground itself was violently stirred and then abruptly settled. This entire hemisphere of Mars is notably lower than the rest, a subtle dip in the planet's topography. This geological clue, combined with the appearance of these outflow channels, which bear a striking resemblance to river channels on Earth, strongly suggests that they once flowed into a vast ancient ocean. Ground-based rovers, our patient explorers on the surface, have since uncovered further evidence for this once-present ocean, finding hydrated minerals in these regions, subtle crystalline whispers of a wetter past, gently confirming the whispers from above. Another truly interesting visual landmark on Mars, captured with quiet elegance by Mangalyaan, is Case Valles, located north of Valles Marineris. Again, this feature showcases a very interesting outflow channel, beginning in the east and gently flowing to the west, eventually depositing its ancient waters into the same vast region that Valles Marineris emptied into, though further north. Most scientists propose that these colossal channels, so wide and deep, were carved out by mega-flooding events in the distant past periods, when liquid water was abundantly present on the Martian surface, perhaps released suddenly from beneath the ground. There is also a quiet argument that immense glaciers moving with ponderous slowness might have carved out these channels. Indeed, there are many outflow regions heading into this once ocean like ancient tributaries, feeding a forgotten sea. Here too, we see Aries Valles, another grand channel probably carved out by similar mega-flooding events. The sheer width of all these channels suggests that they were too vast to have supported a constant river system, at least at this immense size. They speak instead of cataclysmic, yet ephemeral flows, leaving behind an enduring legacy on the Martian surface. Then there is Orcus Patera, a very large, yet oddly shaped crater-like structure, observed with quiet bewilderment in the Mangalyaan images. At its longest point, it stretches for 380 kilometers, a truly immense feature. However, scientists are a bit baffled about how this could have formed. Traditional impact craters born from the forceful kiss of celestial bodies are always circular, like perfect cosmic bullseyes, but Orcus Patera is distinctly elongated, and it's also not very deep, only 500 meters. Volcanic activity could be a possible cause, but there's no clear caldera, no telltale sign of a collapsed volcanic vent that would explain its unusual shape. So far, there have been no theories that scientists can fully settle on leaving Orcus Patera as a quiet enigma, a silent question mark etched into the Martian surface. What do you think it could be? A gentle invitation to wonder, to let your imagination wander across the vast, mysterious plains of Mars. Some of the images captured by Mangalyaan, focusing on the very limb, the delicate edge of the planet, have also offered us a glimpse into Mars's atmosphere, a truly beautiful and ethereal sight. Imagine a faint glowing halo surrounding the ruddy sphere, a thin precious envelope of air. Some very oblique shots, taken at a gentle sidelong glance, have even been able to reveal a cloud layer suspended high in the Martian atmosphere, like a delicate, transparent veil. And due to Mangalyaan's elliptical orbit, which occasionally brought it into a unique alignment, there were moments when Mars's moon Phobos, a small potato-shaped satellite, came between the planet and the probe. In these rare fleeting instances, Phobos was imaged against the magnificent backdrop of the planet, a tiny dark silhouette dancing before the vast, glowing expanse of Mars itself. These are quiet, serendipitous captures offering profound moments of cosmic artistry. The last thing Mangalyaan silently showcased, even from its zoomed-out perspective, was the subtle yet powerful influence of the prevailing wind direction on some parts of the Martian surface. In one image, spanning a few thousand kilometers across, we could clearly see where craters like tiny stubborn obstacles had blocked the darker dust from moving across the surface with the wind. It's a silent testament to the constancy of the Martian breezes, for the wind direction in these parts must have been remarkably consistent for a considerable while for it to leave such a noticeable pattern. Visible even from the distant gaze of space. A closer look at the surface, though not specifically provided by Mangalyaan, but understood through other missions, shows how this same gentle persistent effect can happen with even smaller craters, each one leaving a tiny wind-swept shadow in its wake, an enduring record of the Martian atmosphere's quiet breath. As we gently transition our thoughts, we observe that the years 2020 and 2021 marked significant milestones for Mars exploration, a quiet chorus of new voices joining the cosmic conversation. 3 different missions to the Red Planet were launched from 3 different countries in 2020, the United States, China, and the United Arab Emirates. There was a unique launch window in the summer of that year, a celestial alignment where Earth and Mars were in an optimal position, like 2 dancers gracefully approaching each other, allowing spacecraft to arrive quickly and efficiently. And remarkably, all of them save for the China rover mission, which was still awaiting its gentle touchdown, had successfully reached their distant destination. This new wave of exploration, a testament to humanity's enduring fascination with Mars, promised to unveil even more of its subtle secrets, painting an ever richer portrait of our mysterious planetary neighbor. The Hope mission, beautifully named Al-Amal, represented a truly bold and significant leap for the United Arab Emirates. It was their very first attempt to reach Mars, and in a remarkably ambitious move, they bypassed any intermediate steps, like lunar missions, choosing instead to go straight for the Red Planet. This decision itself was a quiet statement of intent, a declaration of their commitment to high-level space exploration. The mission was designed as an orbiter, with a specific and pioneering goal to become the first true weather satellite around Mars. Imagine for a moment a vigilant eye gently circling a distant world, patiently observing the subtle shifts and grand patterns of its atmosphere, charting its climate with unprecedented detail. This was the quiet ambition of Hope. Alex Molin, our guide, wisely invited us to consider what exactly such a weather satellite would entail for Mars. It speaks to a deeper understanding, not just of what the Red Planet is, but how it behaves. The United Arab Emirates Space Agency, created in 2014, had a clear vision to ignite interest in space science research and exploration within the Arab nation. This endeavor was part of a larger gentle transformation underway in the UAE and other Arab countries, a concerted effort to diversify their economies away from oil, to invest their wealth not just in immediate gains, but in the long-term prosperity of knowledge and technology-based industries. This commitment to a knowledge economy is wonderful news for space exploration. For as the space agency has already stated, they intend to share all the resulting mission data internationally. This spirit of openness of contributing to the global pool of knowledge is a quiet act of generosity in the vastness of the cosmos. Hope's journey was built on a foundation of international collaboration, a gentle weaving together of expertise from across the globe. It was constructed with vital support from the University of California, Arizona State University and the University of Colorado Boulder, where the spacecraft was eventually assembled. Imagine minds from different cultures, different academic traditions, coming together patiently, pooling their knowledge and skill to create this delicate marvel. The UAE also wisely collaborated with India's space program ISRO drawing on their invaluable experience, as ISRO had already successfully sent a probe to Mars years prior. This willingness to learn to partner to share the burdens and joys of such a grand undertaking is a beautiful reflection of humanity's better nature. After 5 years of meticulous planning and construction, a period of patient, steady work, the Hope probe was finally ready. It was launched on a Japanese rocket from the Tanegashima Space Center in Japan on the gentle summer evening of July 19, 2020. Then began the long cruise through the silent expanse of space, a journey of 7 months, where the probe simply drifted a tiny determined messenger heading towards its distant home. Finally, on February 9, 2021, Hope performed its orbital entry maneuver, a crucial and delicate dance of propulsion and gravity, and it was a resounding success. This quiet triumph made the UAE the fifth country to reach Mars, and perhaps even more impressively, the second country to successfully enter a Martian orbit on its very first attempt, following in the gentle footsteps of ISRO. It was a moment of profound pride, a quiet cheer echoing across continents as a new nation joined the ranks of spacefaring explorers. As mentioned, the HOPE mission was designed to collect scientific data while in orbit around Mars, specifically observing Mars's climate and atmosphere. But how does one decide what to observe on a distant world? The process was thoughtful and collaborative, like a conversation among wise elders seeking the hidden truths of the universe. While designing the spacecraft, a consultation was made with NASA's Mars Exploration Program Analysis Group. The goal was to identify the gaps in our current knowledge of the planet, to find the quiet corners of mystery that still eluded us. As a result of this thoughtful consultation, HOPE was equipped with 3 specific scientific instruments. These instruments were carefully chosen to help it detect water vapor and water ice in the atmosphere itself, to measure the atmospheric temperature, and to search for trace amounts of oxygen and hydrogen particles that had subtly escaped into space. Additionally, it carried a high-definition digital camera, which had already captured some truly fantastic images, offering us a visual feast of Mars's ever-changing face. So why these particular instruments, one might gently ask? The answer lies in one of HOPE's core science goals, to investigate the profound absence of water on the surface of Mars. It is a striking reality that Mars cannot contain liquid water on its surface, naturally a stark contrast to our own blue planet. This is due to its thin atmosphere, a delicate veil that offers little protection. You see, on Earth, the higher up in altitude you go, the lower the boiling point of water. This is because at higher altitudes, the atmosphere is thinner, meaning there is less air pressure exerted on the water. On the very peak of Everest, for example, water boils at a mere 70 degrees Celsius. On the surface of Mars, the atmospheric pressure is equivalent to being 30 kilometers up on Earth, an incredibly thin embrace. This means that water, if it were to appear, would evaporate almost instantaneously, like a whisper disappearing on a strong breeze. But Mars wasn't always this way, cold and arid. Previous Mars missions have returned tantalizing evidence that Mars may have once had a thicker, warmer atmosphere and even vast oceans of liquid water. Early in its history, a vibrant blue counterpart to the cold, dry atmosphere it has today. This stark transformation from a potentially water-rich world to a parched desert leads us to suspect that Mars has since lost most of its atmosphere to space. And this is where the HOPE mission, in gentle collaboration with NASA's MAVEN spacecraft, which is already gracefully orbiting Mars, will help us to understand why this is happening. It's like piecing together a cosmic puzzle, each mission contributing a vital piece to the larger picture of planetary evolution. To understand this atmospheric loss, we must consider the quiet, persistent work of our Sun. Our Sun constantly emits very high-energy photons, tiny packets of light that carry immense power. These photons, upon reaching the Martian atmosphere, gently yet powerfully smash into the atoms present, knocking their electrons off. This process transforms neutral atoms into ions particles with a negative charge, setting them adrift. As the solar wind, a stream of charged particles from the Sun passes the planet. Most of these newly formed ions are gently carried away, drawn by the magnetic field contained within the solar wind itself. This process is called sputtering, a continuous, subtle erosion of the atmosphere. Even if the ions don't leave the atmosphere themselves, they may softly collide with other particles, nudging them out instead. Sputtering is a constant cosmic hum happening all the time, but its effectiveness gradually weakens over time as the Sun grows older and less active, its fiery heart beating a little more gently. Billions of years ago, when Mars may have been enveloped in a thick protective atmosphere, sputtering would have been happening at a far more rapid rate compared to today. Imagine a vast invisible river constantly carrying away tiny fragments of the atmosphere. Over the course of those billions of years, Mars is presumed to have lost more than 65% of its original atmosphere. Even our own Earth, this vibrant living planet, gently loses hundreds of tons of its atmosphere every single day due to radiation and sputtering. However, Earth is blessed with global processes that continually replenish its atmosphere like a never-ending wellspring. More importantly, Earth possesses its own powerful magnetic field, a vast invisible shield that helps to deflect much of the solar wind, gently pushing it around our planet. As a result, our atmosphere doesn't interact with the solar wind as directly or as harshly as Mars's does. On Mars, there is nothing to stop the solar wind from directly interacting with the delicate Martian atmosphere. Imagine a constant, gentle but relentless cosmic breeze slowly eroding the planet's very breath. Mars probably did have a magnetic field, a protective embrace until about 4 billion years ago. But for some profound, still mysterious reason, the dynamo in its core, the deep churning engine that generates a magnetic field, simply stopped. Mars's lower mass and density compared to Earth's might be a reason for this. Theory suggests that Earth's magnetic field is the beautiful result of a dynamo effect caused by the gentle rotation of the planet's liquid outer core around a solid inner core. It's like a cosmic silent washing machine, constantly churning to generate its protective field. Mars's lower mass and density probably resulted in its interior cooling much more rapidly than Earth's, completely solidifying Mars's core. This might be why we still have our vibrant magnetic field, a guardian against the solar winds, and Mars doesn't. Interestingly, investigating Mars's ancient dynamo is something NASA's InSight mission is still trying to do right now. Listening to the planet's quiet tremors to understand its deep inner life. So how can the HOPE mission with its gentle, watchful eye help to investigate what's truly going on with Mars's atmospheric loss? And what will it do that is different yet complementary to NASA's MAVEN spacecraft? Imagine two careful observers, each with a different vantage point, piecing together a complex story. Whereas MAVEN has an extremely elliptical orbit designed for up-close observations of the upper atmosphere, HOPE will gracefully stay further out. This higher, more distant perch allows it to maintain a daily global view of Mars, like a patient cartographer, continually updating a planetary map. From this wide embrace, HOPE can keep meticulous track of the Martian seasons, observing the subtle shifts in climate and following grand weather events like Mars's famous dust storms, watching their slow, powerful unfurling across the planet. Maintaining a high orbit means that these large-scale weather events can be tracked with ease, and their progression can be compared to other regions of the planet simultaneously. It's like having a universal perspective, seeing the entire planetary system breathe at once. Furthermore, HOPE will also be able to gently detect particles as they leave Mars's atmosphere, tracing their quiet escape into the vastness of space. This information will hopefully help MAVEN map atmospheric loss events even better, painting a more complete picture of how much of Mars's essence is slowly drifting away. The quiet combination of these two different data sets, the close-up detail from MAVEN and the sweeping global view from HOPE, will help us get a much better handle on precisely how much atmosphere Mars actually loses to sputtering, giving us a clearer understanding of its planetary metabolism. The HOPE mission also aims to find more subtle evidence to gently probe questions like, did Mars ever truly have a warm and thick atmosphere? Was there, in fact, liquid water on its surface flowing in ancient rivers and pooling in forgotten lakes? And could it have once been a place habitable for life, a quiet cradle for microbial beginnings? These are not mere scientific inquiries. They are profound philosophical questions reaching into the very nature of existence. You may gently wonder why this is relevant to you, why the fate of a distant dry world should touch our lives here on Earth. But what we learn about Mars, its dramatic transformation from a potentially vibrant world to the one we see today, will also help us understand more about how Earth itself formed and evolved. We'll be able to compare the processes that unfolded there with what we may expect to happen to our own precious planet over the vast stretches of cosmic time. Over the course of HOPE's initial 2-year mission, it is expected to provide a wealth of data, a gentle cascade of information that will better place us within the vastness of the universe and the intricate workings of the solar system we inhabit. Each data point, each image, each new insight is like a tiny luminous star illuminating our path of understanding. And as HOPE continues its quiet, diligent work, patiently charting the Martian skies, it contributes to a grander narrative, one that speaks to our collective yearning to understand our place in the cosmos, to listen to the whispers of other worlds, and to reflect on the delicate balance that sustains life. It is a mission of hope, not just for the UAE, but for all of humanity, a gentle reminder that curiosity is a boundless journey stretching into infinity. Let us now shift our gaze to another remarkable feat, a testament to the quiet art of precision, a mission affectionately nicknamed Moon Sniper. This is the story of JAXA's SLIM or Smart Lander. For investigating Moon, a small lightweight spacecraft about the size of a passenger vehicle, its primary mission was not simply to touch down on the lunar surface, but to demonstrate an unprecedented level of accuracy to prove that we can now land not just on the Moon, but exactly where we intend to. Imagine aiming a whisper from London and having it land softly on a specific grain of sand in Cairo. That was the breathtaking ambition of Moon Sniper. SLIM's scientific mission, though secondary to its precision landing demonstration, was no less profound. It aimed to analyze the composition of olivine rocks near the Scioli crater, a fascinating location some 200 miles south of the Sea of Tranquility, where Neil Armstrong took his famous small step. This particular landing zone was chosen with exquisite care as it sits on ground ejected by the nearby crater. This geological gift offers researchers a unique chance to study pristine lunar rock without the need for cumbersome drilling, a more gentle and direct way to uncover ancient secrets. By meticulously analyzing the rocks in this specific spot, JAXA quietly hoped to unravel more about the Moon's profound origins, its mysterious interior, and the very processes of its formation. It was a quest to listen to the Moon's oldest geological whispers, to understand the foundational elements of its silent existence. Beyond its scientific aims, SLIM carried a deeper, more philosophical purpose. It was a showcase of the latest in engineering and mission operations, a gentle flexing of technological muscle. Its core goal was to demonstrate how a small, lightweight explorer, unburdened by the vast complexities of larger crafts, could execute accurate lunar landing techniques. This was not about grand gestures, but about precise, elegant control. Such capability, if proven, would accelerate the study of the Moon and other planets by ushering in an era of lighter, more precise exploration systems. Imagine a future where we could send a delicate scout to touch down on treacherous rocky terrain, previously deemed too difficult or too dangerous for larger, heavier crafts. This innovation promises to unlock new frontiers, allowing us to whisper our scientific questions directly onto the most challenging landscapes of distant worlds. To truly appreciate the quiet revolution that Moon Sniper represents, it helps to gently place it within a historical context. The first thing one must understand is the sheer difficulty of lunar landings. Historically, only about 43% of lunar landing attempts have been successful. Imagine flipping a coin and knowing that almost every other time your carefully planned endeavor would falter. Past lunar missions faced huge limitations in landing accuracy, primarily constrained by the nascent technology of the time and the unforgiving lunar environment. For example, the Soviet Union, in its pioneering zeal, took a dozen painstaking attempts before they finally landed Luna 9 successfully on the Moon. Similarly, NASA's Ranger series endured 6 tries before achieving success. Each attempt was a quiet act of courage, a delicate dance with the unknown, often ending in silence. The Moon's complete lack of atmosphere means that landers cannot use parachutes to slow their descent, nor can they gracefully glide. They rely solely on engine thrust, For deceleration, a continuous powerful push against the moon's gravity. This complicates the ability to adjust trajectories accurately during landing, making it a perilous ballet of finely tuned engines. The craft must touch down at near zero speed, like a feather settling onto a still pond, to ensure no delicate instruments on board are damaged from the impact. Every single Apollo mission, those iconic giants of human endeavor, landed dangerously close to rocks, craters, or slopes that could have caused serious damage with very limited ability to make real-time adjustments. It was a testament to the skill of the astronauts in ground control, but also a stark reminder of the inherent risks. The Apollo missions also made another practical, yet limiting choice. They all landed on the near side of the moon, close to the equator, and in almost perfect lighting conditions. This was done to make touchdown as safe and predictable as possible, ensuring clear communication and optimal visual conditions. The downside of this, however, was that NASA was continually sending spacecraft to the same general patch of moon, like continually plucking fruit from the same branch of a vast tree. This meant that actual exploration of the surface was largely limited to this specific landing zone. Imagine a world of boundless wonder, yet our access confined to a few familiar pathways. If we could make a spacecraft capable of landing in a super-precise zone, we could send it to explore whatever and wherever we liked. Scientists would be able to carry out targeted studies of different rocks and soil types without relying on rovers to travel long distances, reducing mission complexity and cost, and gently opening avenues to explore entirely new lunar regions, hidden gems waiting to be discovered. The shift in precision from the broad strokes of earlier landings to the pinpoint accuracy of Moon Sniper is truly remarkable. Back in 1969, Apollo 11's targeting ellipse, the area of uncertainty for its landing zone, was a sprawling 18.5 kilometers by 4.5 kilometers. Imagine a vast oval garden, and your goal is to land anywhere within it. Fast forward to 2013, and China's Chang'e 3 launched with a significantly tighter landing ellipse of 6 kilometers by 6 kilometers. Still a considerable area, but a step towards greater control. Then, in January 2024, the JAXA lander SLIM made Japan the 5th country to gently touch down on the moon. And its accuracy. It landed just 55 meters from the very center of its 100 meter by 100 meter target ellipse. Think of that, a target 325 times smaller than Apollo 11's. It's like hitting a specific teacup on a table across a vast stadium, a testament to an almost unimaginable leap in precision. This unprecedented accuracy was made possible by Moon Sniper's sophisticated vision-based navigation system, which JAXA affectionately refers to as Smart Eyes. Imagine a diligent, tireless cartographer constantly scanning the terrain, comparing what it sees with a meticulously prepared map. As the spacecraft gently descended towards the lunar surface, its smart eyes continuously captured images, processing them in real time. This allowed the spacecraft to precisely locate itself moment by moment on orbital maps that had been painstakingly created, using data from other lunar missions, including NASA's LRO India's Chandrayaan-2 and Japan's Selene. These precise positions were then matched to a broad map encompassing its location, enabling the lander to determine its exact landing site with breathtaking accuracy. This real-time processing of images allowed Moon Sniper to adjust its trajectory literally on the fly, a delicate dance of calculation and correction, enabling it to hit its tiny target with pinpoint accuracy, a true testament to silent, intelligent design. Weighing a mere 200 kilograms without propellant, SLIM was designed as a small, lightweight spacecraft. A successful landing, therefore, would not only demonstrate its precision, but also prove that such compact and nimble explorers could indeed accomplish complex lunar exploration missions. This concept holds immense promise for the future, opening doors to more frequent, more specialized, and perhaps less costly missions. However, despite this exquisite precision, SLIM didn't exactly stick the landing as gracefully as one might have hoped. While JAXA admirably managed to land the craft precisely on target, it sort of toppled over at the very last minute, like a tired traveler finally reaching their destination, but losing their balance. This unexpected tilt presented a new poignant challenge for the resilient little craft. What could have caused this grave malfunction after such a precisely executed approach? The journey began gently enough. On September 6, 2023, JAXA launched SLIM, setting it on its quiet course for the Moon. It arrived gracefully in lunar orbit on Christmas Day 2023, a silent gift in the cosmic expanse. The final approach for landing commenced on January 18, 2024. As Japan watched intently, the approach was live-streamed, a moment of shared breath across the nation. One mission team member, with quiet understatement, dubbed the deceleration to landing as an expected to be a breathless, numbing 20 minutes of terror. And indeed, it proved to be a nail-biting descent to the lunar surface. In those critical moments, a mysterious event occurred. One of SLIM's two main engine nozzles mysteriously detached roughly 50 meters above the Moon's surface. Imagine a delicate wing suddenly faltering just before touchdown. This unforeseen detachment caused an off-center thrust, which in turn caused the lander to gain an unintended lateral motion, a gentle sideways drift. The incredible thing, however, is that SLIM, with its inherent intelligence, was able to identify this anomaly in its descent. It then courageously attempted to stabilize itself, and remarkably succeeded, using its smaller thrusters to counteract the imbalance like a skilled dancer, subtly adjusting their posture mid-performance. This allowed it to find a safe spot to touch down, avoiding a catastrophic crash, a testament to its quiet resilience even in unexpected adversity. Despite its valiant efforts to stabilize, SLIM ultimately tipped over onto its nose like a child's toy, finally resting after a long journey, as seen in the poignant images from one of two autonomous probes that SLIM had released just before its touchdown. We see the box-shaped main vehicle on the surface of the Moon distinctly upside down, its vital solar panels pointing away from the Sun instead of gently angled upwards as planned. Without the life-giving light from the Sun, it was only a brief matter of time before the craft would inevitably run out of energy and fall silent. Soon after landing, however, with its limited battery power, SLIM managed to send back a mosaic image of its landing site, a final beautiful postcard from its initial moments on the Moon. With just 12% of power remaining, JAXA made a quiet, hopeful decision. They switched the craft off, nurturing the faint possibility of a recovery when the Sun's angle would eventually shift. And indeed, just 10 days later, on January 29th, that's precisely what happened. The Sun, in its majestic cosmic dance, had shifted its angle in the lunar sky, gently caressing SLIM's panels with its light. For 2 short, precious days, SLIM was able to power on, sending back whispers of data and images from the lunar surface. The elation, however, was tempered with a quiet understanding within the JAXA team. The brutal lunar night was approaching a period of profound darkness and extreme cold that would likely spell the end of their revolutionary little spacecraft. Lunar nights are a formidable challenge for all moonbound missions. They are absolutely brutal. It's not uncommon for mooncraft, even robust ones, not to survive a lunar night. For example, the first U.S. craft to make it to the Moon. In 50 years, the U.S. lander Odysseus tragically failed to awaken following a lunar night. Much like SLIM, it had malfunctioned on approach and landed on its nose in early 2024. Despite going into hibernation mode for 3 weeks, it did not wake up again, a silent end to a promising journey. Since the Moon possesses virtually no atmosphere, there is nothing to stabilize its surface temperature. Imagine a bare rock in the vastness of space, completely exposed to the Sun's relentless heat and the deep chill of shadow. During a lunar day, when the Moon is gently facing the Sun, temperatures can soar to a blistering 121 degrees Celsius, hot enough to bake instruments. But during a lunar night, the Moon is plunged into total darkness and temperatures plummet to an average of 180 degrees Celsius. That's quite the whiplash for our little lander, a sudden swing from extreme heat to unimaginable cold. What's more, days and nights on the moon aren't like the familiar 12-hour cycles we know on Earth. They last a grueling 14 Earth days each. That's a fortnight of searing heat, followed by a fortnight of total freezing darkness. SLIM was simply not designed to withstand such a harsh, prolonged lunar night. So on January 31st, the mission team, with a sense of quiet resignation, put it into a hibernation state for the next 14 days. It was not expected to survive, but the hopeful crew, holding on to a sliver of possibility, decided they would try to establish contact after the sun rose again, just in case a silent prayer whispered into the void. And then a true miracle, a quiet defiance of expectation. On February 26th, JAXA attempted to re-establish contact with SLIM with very few expectations. Imagine their total shock and profound elation when SLIM responded a faint, persistent signal echoing across the vast distance. Their miracle moon sniper had survived its first lunar night and had begun sending pictures back to Earth, a gentle whisper of resilience from the desolate lunar surface. It gets even better. After 2 weeks of diligently collecting data and images during its second lunar day, JAXA set SLIM into hibernation once again. Surviving one lunar night is no small feat, a triumph against overwhelming odds. No one, not a single soul, expected SLIM to survive a second one. But somehow, against all conventional understanding, it did. On March 21st, JAXA confirmed they'd received more communication from SLIM following its second lunar night, a repeated whisper of life. The pattern of quiet resilience continued into late April, when even more pictures were sent back from the lunar surface following its third lunar night. SLIM had totally defied the odds, maintaining its functionality through intense levels of heat and cold, which would utterly destroy most electronics not specifically designed for these brutal conditions. Somehow, this tiny, unassuming craft, designed for precision landing, but not prolonged endurance, still managed to send back data and images after 3 lunar nights. These precious images of the surrounding moon rocks, captured with quiet determination, will help researchers better understand lunar geology. In one image, SLIM took a close-up photo of a moon rock affectionately nicknamed Toy Poodle, using a special multiband camera. Despite a slight blur, geologists can use this to gently distinguish between the different materials that make up the rock, offering subtle clues as to how the moon itself formed a quiet unraveling of cosmic history. Following the 4th lunar night, JAXA attempted once again to re-establish communication with SLIM. However, as of May 27th, they've been unable to confirm successful communication with the moon sniper. Despite all its heroic efforts, its quiet, persistent defiance, it's likely it has finally fallen silent. Once and for all, its long, quiet watch over the lunar surface concluded. Still, JAXA's first lunar touchdown remains a profound breakthrough in interplanetary travel, a gentle but firm demonstration of what is now possible. Demonstrating the feasibility of such pinpoint landings opens the door to many other possibilities, like unlocking hidden chambers of lunar ice. One key area of profound interest to scientists, now more accessible, is the South Pole Aitken Basin, a vast ancient scar where the moon's mantle is suspected to have once been exposed on the surface. NASA is also planning a return to the moon in 2026 with the launch of their Artemis missions. Pinpoint touchdowns like the one executed by Moon Sniper (EP) may prove vital in helping us gently reach water ice lying in permanently shadowed regions, areas that until now have remained largely inaccessible, like hidden treasures guarded by eternal twilight. Moon Sniper stands as a silent testament to all the progress and innovation we have achieved since the last lunar era of the late 60s and early 70s. As both public and private interest in revisiting the moon continues to grow, missions like Moon Sniper offer us a quiet glimpse into what the second lunar era might have in store for us, a future of gentle, precise exploration. Let us now turn our attention to a story that, while perhaps less globally celebrated than the grand lunar landings, holds a unique and poignant place in the annals of space exploration. This is the tale of Prospero, a satellite that circles Earth even today, a silent sentinel, marking 50 years since its launch on October 28, 1971. And there is something strangely sad about this unique satellite, for it only ever ran a couple of scientific experiments, and yet it will likely remain in orbit for another 50 years. But from its quiet journey, we can glean inspiring lessons, a gentle reminder of the fleeting nature of ambition, and the enduring power of knowledge. Why, one might gently ask, is Prospero unique? It is because it represents the only time a nation developed its own rocket capacity to put a satellite into space, and then, with a quiet sigh, later discarded that capability. This is the story of my home nation, the United Kingdom, and the first and only time they launched a satellite into space using a rocket of their own making. The UK's official entry into the space race began in 1962, when they became the third country to operate a satellite in space, following closely behind Russia and the United States. However, that pioneering satellite, Ariel 1, was not launched using a UK-built rocket. Instead, it was gently carried into orbit by NASA. In those heady days, as America and the USSR were rapidly gearing up for their monumental journey to the moon, the United Kingdom, too, was eager not to be left behind to contribute its own unique voice to the unfolding cosmic symphony. The Royal Aircraft Establishment, or RAE, which was perhaps the closest equivalent the UK had to its own dedicated space agency at the time, first quietly proposed the audacious idea of developing their very own rockets in 1963. Up until then, UK rocket science had been predominantly military in nature, focused on the powerful destructive capabilities of ballistic missiles. Rockets like Blue Streak and Black Knight were developed drawing upon the scientific knowledge of German scientists who had been quietly brought to Britain after World War II, much like what happened in America around the same time. These were formidable machines intended to carry nuclear payloads, instruments of earthly power. However, the RAE harbored a different, gentler ambition. They wanted to create rockets that could carry satellites into space for scientific and communication purposes, to build bridges of light rather than weapons of war. Their initial request was modest, but significant: a low Earth orbit rocket capable of carrying a 144 kilo satellite into orbit. The request was approved in 1964, but then, like a gentle breeze suddenly changing direction, it was quickly put on hold due to an upcoming general election. A quiet pause in the grand design. A new government eventually came into power, and with a fresh breath of cautious optimism, restarted the process. However, they immediately introduced a subtle but significant change. They decided to reduce the number of test flights from 5 to 3. This seemingly small alteration was, in retrospect, the very beginning of the slow withering of the UK's indigenous rocket abilities, even before they had truly begun to blossom. It was a quiet decision that would echo through the decades, a gentle tightening of the purse strings that would ultimately shape the nation's space future. Using the robust technology of the Black Knight rockets as a foundation, EO scientists embarked on the intricate journey of developing the Black Arrow. This was to be a 3-stage rocket that, while sharing many of the same technological roots as its predecessor, was considerably more powerful. Imagine an older, reliable engine being refined and boosted, capable of producing an initial 256 kilonewtons of thrust, a significant leap compared to the Black Knight's 96 kilonewtons. The design of Black Arrow was a graceful multi-stage ballet, each part playing its role in the delicate ascent. The first stage, the powerful foundation, would carry the payload for the initial 2 minutes or so of the launch, a mighty roar against gravity, before gently falling away, its task complete. Then the second stage would ignite burning for 2 more minutes, pushing the payload higher and faster before itself splitting cleanly in half, releasing the third stage and the precious cargo. After this separation, the third stage would burn for a brief final minute, a quiet push towards the orbital embrace, and a minute later, the payload and the final stage would gracefully separate the satellite, now free to begin its silent journey around Earth. Parts of the Black Arrow were meticulously constructed around the UK, a national effort with much of the final assembly taking place on the Isle of Wight, a quiet island becoming a hub of cosmic ambition. The launch site itself was chosen far away in Australia, a Commonwealth country. Other test sites closer to home had been considered, but in the end, it was decided that the risk of spent rocket parts falling on populated locations in the UK was simply too great a cautious decision, prioritizing safety over convenience. However, the Wilson government of the day was navigating difficult financial waters, like a ship caught in a gentle but persistent current of economic strain. They were actively seeking ways to reduce outgoing costs to balance the national books. They had another grand project underway at the same time, one that was demanding substantial investment: the supersonic airliner Concorde, a symbol of modern aviation. Ironically, the UK government, in its quiet calculation, decided that Concorde held the better long-term prospects for the UK economy than satellite technology. This was, in hindsight, a poignant miscalculation, for Concorde ultimately ended up grounded altogether in 2003, a majestic bird that eventually ceased its flights. It wasn't that they didn't believe satellites would benefit the economy. It was a matter of internal disagreement. No one could quite agree on who should cover the substantial development costs, leading to a gentle, persistent deadlock. On top of these financial hesitations, the Black Arrow program began to encounter technical problems, subtle whispers of difficulty in its complex machinery. Although its maiden flight testing, its first 2 stages, was scheduled for 1968, it wasn't until 1969 that the first Black Arrow finally launched. And that launch, alas, was a failure. An electrical fault, a tiny unforeseen glitch, caused some of its combustion chambers to pivot unexpectedly, causing the rocket to roll erratically, like a graceful dancer, suddenly losing its balance. It ended up disintegrating and was ultimately completely destroyed, a quiet, unfortunate end to its first grand ascent. The second launch, where it was testing the first 2 stages again, went off successfully, a momentary breath of hope. But the Black Arrow's third and final test, launch its first brave attempt to reach a full orbit, was also a failure. Its second stage suffered from an oxidizer that failed to pressurize, meaning that the second stage cut out early, and the whole rocket with its mock payload, SOM, failed to reach orbit. In this quiet period of struggle, other nations with their own rising ambitions were finding success. France, Japan, and China all successfully launched satellites using their own rockets. And so the quiet decision was made. On July 29, 1971, the UK government, facing persistent financial constraints and a series of technical setbacks, decided to cut its losses and formally cancel the Black Arrow project. This was a great blow to the Upper EE, a heavy silence descending upon their dedicated work. However, by this time, the fourth Black Arrow rocket had already been meticulously constructed and shipped to Australia, along with its accompanying satellite. In a final gentle gesture, the government finally gave the go-ahead for this very last launch. This satellite, the culmination of so much quiet effort, was specifically designed to test the critical technologies necessary for communicating with satellites. As such, it carried delicate tape recorders, a micrometeorite detector designed to measure the subtle frequency of tiny particles in space, and multiple designs for solar cells intended to determine which would be the most effective in the harsh embrace of orbit. Initially, this satellite was named Puck by the RAE, a continuation of the gentle tradition at the time of RAE satellites being named after Shakespearean references. Puck, like his predecessor Ariel, were both fairy characters in Shakespearean plays, mischievous beings of the air associated with pranks and magic. But when the entire project was quietly canceled, the RAE team, with a sense of poignant reflection, changed the name of the satellite from Puck to Prospero. Prospero, a powerful sorcerer in Shakespeare's play The Tempest, was a masterful magician too, but ultimately, in a gesture of profound wisdom, he gave it all up to become a normal human. It was a sharp, perhaps melancholic indicator for how the RAE team must have felt. Although they would be allowed to launch their very last rocket, they knew with quiet certainty that they would never do so again. Britain, it seemed, was gently giving up on its own unique participation in the space race. It would in the future opt to pay other nations to carry its satellites into space, a decision considered more economical. To the dedicated RAE scientists, it must have felt like they were relinquishing the magic, a quiet surrender of a grand dream. This made the successful launch of Black Arrow and Prospero on October 28, 1971, all the more bittersweet, a quiet, poignant triumph shrouded in the knowledge of finality. Before this moment, a Black Arrow had not successfully carried a payload all the way to low Earth orbit. And now, just when it had finally proven its viability, just when its quiet potential had been beautifully demonstrated, the program was ended. Admittedly, Prospero's launch didn't go completely smoothly. As the third stage of the Black Arrow rocket came away, one of its thrusters kept firing and gently clipped Prospero on the way past. Fortunately, while this knocked off one of Prospero's 4 antennae, the satellite remarkably maintained a stable orbit and was able to go on to have a successful mission. It quietly taught British scientists much about designing satellites for space, a precious knowledge that would come in useful as Britain went on to quietly specialize in the field of satellite technology, becoming a respected player in a different, perhaps less visible aspect of the space industry. The public reaction to this quiet triumph was perhaps the most telling sign of its bittersweet nature. Unlike in other nations, such as the US, where the successful launch of their first satellites made headlines and ignited national pride, Prospero's achievement didn't even make the UK front-page news. The public barely noticed it happened. It was a full 2 days later before any newspapers even mentioned it, a quiet footnote in the busy news cycle. The UK government acknowledged that the successful launch was excellent news, but with a firm resolve, did not restart the program. Britain became the 6th nation to launch a satellite into space using their own rocket, a quiet achievement that seemed destined to fade into historical obscurity. In 1973, Prospero's tape recorders, its listening ears, stopped working, a gentle dimming of its functions. It could still be contacted, its faint signal still detectable, but government scientists eventually stopped doing so when they closed their satellite monitoring station in 1996. Prospero was officially deactivated, its active mission concluded. However, it didn't immediately fall silent. Amateur satellite enthusiasts with a persistent and gentle curiosity continued to contact Prospero until about 2004, where its faint signal, powered by its enduring solar panels, could still be heard, a distant, whispered hum in the cosmic ether. As we neared the end of October 2021, we approached the 50-year anniversary of Prospero's launch. Although Prospero had by then gone silent, its faint whisper no longer detectable, and that might have been the quiet end for Prospero and the Black Arrow project, if it hadn't been for an unexpected twist in the tale. Thanks to the massive and somewhat unexpected growth of the space industry in the 2010s, the UK government, with a renewed sense of purpose, decided to gently get back into space. It created the UK Space Agency and began building several spaceports, quietly developing once again its capability for rocketry. And thanks to the significant advances made in satellite technology in the intervening years, satellites are now much smaller than they used to be a few decades ago. As such, only a smaller rocket is needed to carry such payloads into low Earth orbit, a rocket just like Black Arrow, in fact. Black Arrow, it turns out, is so ideally suited for this particular niche that an Edinburgh-based space technologies company, Skyrora, has heavily based their rockets on its very design. Their Skyrora XL rocket has similar dimensions to the Black Arrow and uses the same type of kerosene and hydrogen peroxide mix for their fuel, a gentle homage to a quiet, forgotten pioneer. In 2018, the company quietly acquired the remains of Black Arrow R3, not for scientific study, but to proudly display them in their offices, a gesture of profound respect for the legacy of this great rocket. And crazily enough, as part of an effort to gently remove space debris from orbit, they even have plans to find Prospero and bring it back down to Earth intact. So perhaps Prospero will not end up lonely and forgotten after all. Although it seemed for almost 50 years that Prospero and Black Arrow were a mere footnote, a failed experiment, as part of an effort that was doomed before it even began, their legacy is proving much more influential than any of the array scientists could have predicted at the time. And perhaps, just perhaps, the magic does not need to be given up after all. The quiet seeds planted so long ago are finally blooming, a gentle reminder that even the most fleeting efforts can cast long shadows of inspiration, quietly guiding the path for future generations. No one man truly builds a spaceship. It's a symphony of minds, a delicate dance of countless hands, each contributing a small vital part to a grander vision. The Jupiter Icy Moons Explorer, or UEAE, has just launched, and it would be easy to simply say that ESA, the European Space Agency, made it. But that would gloss over the colossal process, the intricate weaving of dreams and engineering that transformed a vague idea on a design board into a fully realized behemoth of metal and carbon fiber, now hurtling upward through our atmosphere. Building a probe like JUICE is a monumental undertaking, a silent testament to human collaboration. For JUICE, it was a task that involved 18 countries, 60 companies, 11 years of dedicated work, a 5-city tour for its components, and a staggering 1.6 billion euros of technical expertise, specialized equipment, and precious resources. By delving into the quiet story of JUICE's creation, we gain a deeper appreciation for the incredible patient process by which such magnificent craft are made. JUICE launched on April 14, 2023. But that is only half the story. The first half, the one that took place before the probe even left Earth, is a tale of silent dedication and intricate craftsmanship. At the heart of JUICE's mission lies a fascinating secret, a profound whisper hidden beneath the surfaces of Jupiter's icy moons. Callisto, Europa, and Ganymede, all three are thought to quietly harbor deep subsurface oceans, vast bodies of water, some of them larger than the combined oceans here on Earth. Imagine for a moment oceans hidden beneath miles of ice, untouched by sunlight, perhaps warmed by the gentle heat of their rocky cores. These hidden oceans are of immense interest in the scientific community, for such large bodies of water could potentially make these moons habitable. Water, as we gently understand, is one of the key ingredients for life. We have deep-sea ecosystems here on Earth that thrive on nothing else, quiet, thriving communities in perpetual darkness. Could microbes also have formed in the depths of these moons' icy oceans? Without more information about those oceans, it's hard to tell. What exactly do they look like? What are their features? What are they hiding? Where is their liquid, and where is their ice? By better understanding these icy worlds, scientists can gain insight into how they formed and evolved in the past, and can better predict the odds of life emerging in them and other icy worlds outside our solar system. As such, after much quiet deliberation and rigorous proposal evaluation, it was decided on May 2, 2012, that a new mission to explore these enigmatic moons should be launched. JUICE, with its promise of unlocking such profound secrets, quietly beat out budget proposals for a new gravitational wave observatory and an advanced telescope for high-energy astrophysics. It thus became the European Space Agency's main focus for a large-scale mission over the years 2015 to 2025, a grand commitment to unraveling the mysteries of Jupiter's distant, watery realm. But that initial decision was merely the first brushstroke on a vast canvas. JUICE was still only a partially formed idea, a whisper of potential. Even once it was firmly decided that Jupiter's icy moons should be explored, the next crucial question arose, gentle but persistent. What scientific instruments should JUICE carry to unravel their secrets? So just on 28 days after JUICE was announced, ESA reached out to the wider scientific community, a gentle invitation echoing across laboratories and universities, asking them what delicate tools they would like to see on board this grand explorer. The response was a rich tapestry of ideas, a testament to the collective ingenuity of human minds. In the end, a careful selection process narrowed it down to 10 key scientific instruments. These included cameras with a spatial resolution as fine as 2.5 meters per pixel, capable of capturing minute details like a painter's fine brush. Spectrometers designed to pick up subtle features down to a resolution of 75 meters would act like celestial detectives discerning chemical compositions. A laser altimeter would precisely measure distances mapping the contours of the icy surfaces. Plasma and particle monitors would study the energetic environment around Jupiter. Like sensitive antennae, listening to cosmic whispers, a magnetometer would delve into Jupiter's complex magnetic fields, trying to understand their deep, unseen currents. And an ice-penetrating radar, perhaps the most intriguing, would gently peer through miles of ice to see the hidden structures that lay beneath, searching for the telltale signs of liquid oceans. These intricate parts, each a marvel of engineering, would be provided by various member states of the European Space Agency, a collaborative effort involving 16 nations in total. It was a true reflection of the European spirit, a gentle intertwining of national expertise for a shared grand goal. Beyond Europe, the US and Japan space agencies, too, quietly contributed their invaluable instruments and knowledge, transforming JUICE into a truly international endeavor, a cosmic puzzle assembled by many hands. Airbus Defence and Space was ultimately selected as the primary company in charge of building JUICE, a vast and complex undertaking. ESA had meticulously set the grand expectations for the mission, outlining the scientific quests and the technological boundaries to be pushed. But it was up to Airbus to undertake the monumental task of designing, developing, integrating, and rigorously testing JUICE before finally delivering it to the Guiana Space Center in French Guiana, ready for its majestic launch. It would be no easy task, a journey fraught with intricate challenges and demanding an unwavering commitment to quiet precision. JUICE was conceived as a solar-powered probe, a delicate flower of technology designed to thrive in the dim, distant light of Jupiter. This posed a significant challenge, as it would be working at the very limits of how far from the sun solar panels could be expected to function. Imagine trying to power a bustling city with only the faint glow of a distant candle. At 740 million kilometers from the sun, sunlight is incredibly dim, equivalent to only about 3% of what we experience here on Earth. The panels for JUICE would need to be absolutely massive, a breathtaking 85 square meters, to gather enough precious photons to provide the power it needed for its myriad of instruments, like a vast array of outstretched hands, gathering every last drop of light. But power was just one layer of the challenge. Those delicate instruments, the very eyes and ears of JUICE, would need profound protection. Jupiter's environment is not a gentle place. It is filled with intense radiation, a relentless silent bombardment that can easily damage unshielded electronic components. Imagine delicate watch mechanisms exposed to a constant invisible storm. Passing through Jupiter's shadow, too, would plunge the probe into unimaginable cold, with temperatures plummeting to a bone-chilling 250 degrees Celsius. Yet on its long journey, JUICE would also be passing near Venus as part of one of its many gravity assists, meaning it would also need to gracefully endure blistering hot temperatures. It was a delicate dance between extremes, a craft designed to embrace both fire and ice. Furthermore, since its mission was to study magnetic fields, its own internal electronics couldn't create magnetic fields strong enough to interfere with its sensitive sensors, a subtle harmony between its own operations and its scientific goals. And finally, and most profoundly, as there was a sacred chance that it was heading to environments where life could potentially thrive, the utmost gentle care had to be taken to ensure that no Earth-based bacteria would be inadvertently introduced to those pristine environments. This was a silent vow to protect the possibility of alien life, to leave distant worlds as unblemished as possible. Only when its long mission was gently concluded many years from now would JUICE be allowed to crash into the surface of Ganymede, a final quiet embrace with its ultimate subject. These intricate designs, these layers of protection and precision, naturally took time. It was a slow, deliberate process, like weaving a complex tapestry thread by painstaking thread. It wasn't until 2017 that Airbus, with a quiet sense of accomplishment, felt that the designs were finally complete, ready to be transformed from lines on a screen into tangible reality. Later that very same year, the first delicate parts started to come to life, breathing their mechanical breath into existence. One such crucial part was the RIME instrument JUICE's radar for icy moon exploration. JUICE is a big craft, and its RIME radar is a massive, elegant boom, stretching an incredible 16 meters long. It would need to be incredibly sensitive, capable of seeing through 9 kilometers of ice to make out subtle structural details to a resolution of 50 meters, like a gentle penetrating gaze into the heart of an icy world. Testing such a unique and sensitive part involved creating a meticulous model version of JUICE, then gently hanging it below a helicopter like a delicate pendant. This helicopter then flew it over the tranquil fields near Friedrichshafen, Germany. One can only imagine the sight for any residents in the area: a colossal model of a future space probe dangling gracefully from a helicopter, silently scanning the familiar Earth beneath. How far into the Earth was it able to see, one wonders? It must have been a fun, slightly surreal sight for any who happened to cast their gaze skyward. Another vital model of JUICE underwent rigorous thermal vacuum testing in Noordwijk, the Netherlands, at ESA's main facility for spacecraft development and testing, ESTEC. JUICE's delicate parts would need to gently endure the freezing cold of deep space, so technicians there used an immense quantity of liquid nitrogen, a staggering 25,000 liters of it, to chill the chamber down to a bone-numbing 100 degree Celsius. However, as JUICE would also be traveling near heat sources like Venus on its gravity assist, the challenge was to simulate both extremes. So they simultaneously blasted it on one side with an array of lamps and mirrors, raising the temperature to a blistering 200 degrees Celsius. The JUICE model remarkably proved capable of gracefully enduring these incredible temperature variations, a testament to its robust design, a silent promise of its resilience in the cosmic extremes. Yet these were merely models, carefully crafted replicas. The true JUICE, the one destined for the stars, would soon begin its own quiet, meticulous assembly. The true JUICE, the very vessel that would eventually be launched into the silent abyss, began its physical life in Madrid. There in July 2019, its towering 580 kilo chassis, the very skeleton of the probe, was meticulously assembled. One truly begins to grasp the sheer scale of this magnificent probe by seeing the patient technicians working alongside it, dwarfed by its impressive form. The completed JUICE would eventually weigh a colossal 5,300 kilo, although about 3,000 kilo of that would be the precious chemical propellant it needed to complete its intricate maneuvers, its very breath in the vacuum of space. JUICE indeed needs a lot of juice, a vast reservoir of energy for its distant odyssey. Just a month later, JUICE, in a symbolic awakening, opened its eyes. Its navcam, its navigation camera, had been completed in Toulouse. And what better target for its nascent gaze than its eventual destination? Jupiter, the gas giant, shimmering faintly in a distant image. The image at this immense initial distance was a little pixelated, and the saturation of Jupiter was intentionally bright, a consequence of trying to capture its moons as well. But even before it was fully assembled, JUICE had already cast its first quiet gaze upon its ultimate target, a premonition of its future. But the chassis was not yet ready to fully receive its eyes. there were many more gentle steps in its intricate construction. First, it left Madrid carefully traveling across Europe to Lampoldshausen, Germany, where it would receive its powerful thrusters, one large 400-Newton main engine for its major maneuvers, and 20 smaller thrusters for precise, delicate adjustments like a skilled dancer using subtle shifts of weight. Next, it took a short, careful trip to Friedrichshafen, where its technical equipment, the very heart of its scientific quest, began to be integrated into its robust frame. This lengthy process took a whole year, a period of quiet, meticulous work, as each piece was carefully added and rigorously tested, ensuring perfect harmony. To simulate the gentle weightlessness of space, special balloons were used, allowing the massive 10-meter magnetic boom, a crucial scientific appendage, to practice unfolding itself like a delicate flower slowly opening its petals. Like many spacecraft, JUICE would need to fold itself in, to compress its magnificent form to be able to fit on the rocket that would later carry it into space. But finally, this stage of integration was complete, a quiet milestone achieved. Of course, completion meant more testing was gently in order. JUICE was carefully transported to ISTEC, as it was home to the largest vacuum chamber in Europe, the Large Space Simulator. Getting the colossal JUICE into the even larger LSS was the patient work of 2 days, a slow, deliberate dance of cranes and careful handling. Finally, though, after being painstakingly transported using massive crane equipment, JUICE began its rigorous thermal vacuum testing, enduring the simulated extremes of space. Meanwhile, its individual components, such as its antenna, were put through their paces in ISTEC's unique Blue Room. This specially designed room is an excellent place to practice receiving delicate radio signals, its blue spiky interior doing an excellent job of canceling out all other ambient sounds and stray signals, creating a pocket of perfect silence for testing. RIME's 16-meter antenna was scaled down for these tests to about 80 centimeters to take advantage of the facility's unique capabilities. By using a more optimal frequency, the tests went well, confirming its readiness. And within a few short months, JUICE was gently on the road again, its quiet journey of preparation continuing. This time, JUICE was headed for Toulouse, France, drawing ever closer to its eventual launch site, a subtle acceleration towards its grand destiny. But it had one more crucial step to make along the way: the integration of its magnificent solar panels. What probe would be complete without its life-giving wings? Made up of 356 individual solar cells, each a tiny perfect eye. The panels of JUICE would also fold up neatly before launch, like a sleeping giant, only extending once the probe was safely up in space, ready to drink in the distant sunlight. JUICE was receiving 10 such panels, in total 5 on each side, vast arrays of light-gathering power. And unlike many other components, which would be safely hidden inside protective shielding, these panels would have to gently endure the full brunt of the heat and radiation of space on their own. They also had to be maneuverable, capable of subtle adjustments, as too much energy could cause the internal workings of JUICE to overheat. Power would be regulated carefully, a delicate balance of energy flow. All of this had to be done under the most careful of conditions. Pristine, clean rooms were used throughout this entire process, reducing the risk of even the tiniest speck of dust or bacteria contaminating the delicate equipment, a silent vow of cleanliness. JUICE was running a little behind schedule, a gentle reminder of the immense complexity of such an undertaking. So, in a rare and significant move, it had to be flown into Toulouse, representing one of the first times this had happened for a spacecraft of this magnitude. This last stage of integration and testing was evidently not easy, a prolonged period of intense effort and meticulous checks. It was not until January 2023, a year and a half later, that JUICE was finally ready, its long journey of earthly preparation finally complete. And the rest of the story, perhaps, you may already know or have heard whispered on the cosmic winds. JUICE was carefully taken to French Guiana, and on April 14th, aboard an Ariane 5 rocket, it was gently launched into space. It will now spend the next 8 years patiently traveling through space, performing 3 intricate gravity assists around the Earth and 1 around Venus, a cosmic slingshot gaining momentum. Finally, in 2031, it will gracefully arrive at the Jovian system, ready to begin its careful, quiet evaluation of the icy moons there, the awe-inspiring Ganymede, Callisto, and Europa. In time, and assuming that nothing goes awry, the data and answers it will provide may offer us profound insight into whether life could exist under those frozen surfaces, a quiet hope resonating across the vastness. And eventually, in 2035, its grand mission will come to a gentle end, and it will intentionally crash into Ganymede, a final deliberate embrace with its subject, its mission, hopefully a resounding success. But it's important to recognize just how much of its journey has already taken place long before it could even leave our home planet. JUICE represents a huge engineering feat, a testament to collaboration involving hundreds of people, each a silent contributor. And while we await with eager excitement the results of this monumental work, it is important to recognize and celebrate the expertise that allowed it to come into being. In the first place, the quiet, painstaking efforts that brought this dream to life here on Earth. Let us now turn our gaze towards Venus, our at times closest planetary neighbor, a sister world to Earth, remarkably similar in size, yet profoundly different in almost every other way. Imagine a glowing pearl in the cosmos orbiting the Sun about 40 million kilometers closer than our own vibrant blue marble. For eons, this second planet of our solar system has been the source of stories, myths, and legends, a shimmering beacon in the morning and evening sky that has captivated human imagination. In more recent times, however, we have gone beyond merely seeing that bright circle. We have begun to reach out, to touch, to listen. Beginning at the height of the Cold War, a quiet, determined race unfolded, leading to numerous robotic missions being sent to Venus, each designed to observe, to orbit, and in some brave instances, even to land. And using technology that sees not only in the visible light our eyes perceive, but also in the infrared, ultraviolet, and radio spectra. What we have found is a world that is distinct from Earth in almost every imaginable way. Tonight, we will take a gentle journey to the star of the morning and the evening, using technology, both old and new, to quietly uncover the secrets of Venus, softly descending through its thick atmosphere, to arrive for a fleeting moment at the surface of our closest companion. As the second brightest object in our night sky, outshone only by the moon and often our closest planetary neighbor in terms of distance, Venus has always commanded attention from those who would gaze up at the heavens. Its consistent brilliance, a steady, calm light, has beckoned and puzzled us for millennia. But even today, interplanetary travel is a formidable challenge, a delicate dance of precision and endurance. And at the height of the Cold War, in the early days of the space race, it was even harder, fraught with immense technical hurdles and the intense pressure of global competition. Of the 15 missions launched to explore Venus between 1961 and 1967, a period of fervent ambition, only 3 were ultimately classified as successes in terms of fulfilling their specific objectives. These pioneering triumphs were Mariners 2 and 5 from NASA and Venera 4 from the Soviet Union's Lavochkin Design Bureau. These missions achieved successful atmospheric entries with Venera 4, notably collecting the very first direct atmospheric data from another planet, a quiet whisper of discovery from a distant world. The initial successes of Venera 4, 5, and 6 soon followed, each probe delicately pushing deeper into Venus's mysterious atmospheric envelope. And then, in late 1970, the USSR, with a quiet but persistent resolve, finally passed a massive historic milestone with Venera 7. This intrepid probe became the first spacecraft to achieve a soft landing on the surface of another world, and even more remarkably, to last long enough to transmit back precious information about its hellish environment. Imagine the quiet tension in the control room as the faint signals arrived, confirming contact with a world previously only glimpsed through veils of cloud. Let us now embark on a quiet journey together with that very same spacecraft, tracing its brave descent. Understanding the many layers of the Venusian atmosphere it discovered, and finally, for a fleeting, precious moment, arriving on that scorching surface. Still gently drifting through the silent expanse of space, our Venera probe, now a solitary traveler, slowly turns towards Venus, aligning itself for its brave descent onto the fiery planet. Before it lies Venus's upper atmosphere, an initial thin veil extending from the very fringes of space at around 250 kilometers above the surface and gradually thinning down to about 60 kilometers. Here in this outermost layer, Venera encounters what appears to be nothing but a thin haze, an almost imperceptible breath of air. The reason for this ethereal quality is profound. A staggering 99% of Venus's atmosphere by mass lies densely packed below this point, forming a crushing blanket. This makes Venera's initial descent through this upper thinner layer relatively easy, much in the same way our own atmosphere would feel at similar towering altitudes. It's a deceptive calm before the true storm. But even in this relatively serene upper layer, Venus's atmospheric composition could not be more profoundly different from Earth's. It's a subtle sign of the dramatic changes to come as we and Venera continue our gentle descent. Instead of the familiar majority of nitrogen and oxygen that cradle life on Earth here in Venus's upper reaches, we begin to pick up faint, telltale traces of carbon dioxide. While not yet abundant enough to cause significant warming effects at this altitude, its subtle presence is a crucial marker, a quiet herald of what lies beneath, an ocean of a potent greenhouse gas. Aside from this profound difference in chemistry, however, at these altitudes, the atmosphere behaves roughly the same as that of our home planet, at similar towering heights, displaying vast temperature differences between day and night, a stark contrast between extreme heat and profound cold. The sun-facing side can reach highs of 37 degrees, while the night side plunges to lows of 143 degrees. For Venera, this initial part of the journey is the easy part, a gentle introduction before the true crucible begins. An interesting, almost poetic side note to the noticeable presence of carbon dioxide in the upper atmosphere of Venus is the subtle presence of some oxygen atoms. These oxygen atoms, even in their scarcity, possess a quiet beauty. They emit infrared radiation, a faint invisible glow that can be detected by sensitive telescopes and spacecraft. In a striking picture taken by the Venus Express orbiter, captured in the infrared wavelength, the blue hues eloquently illustrate the airglow caused by these oxygen atoms high in the Venusian atmosphere. It's like seeing a ghostly luminous blueprint of the unseen gases, a silent testament to the gentle interplay of light and matter in the upper reaches of this distant world. As Venera steadily moves downward through the layers of the atmosphere, it inevitably comes to the main visible cloud deck of Venus, a thick, impenetrable veil that begins at around 60 kilometers from the surface. This is the region responsible for the familiar dull yellow appearance that we associate with pictures of Venus taken in visible light. Imagine a colossal mustard-colored blanket, thick and obscuring, stretching downwards and terminating approximately 40 kilometers from the ground. Within this part of the atmosphere, a subtle but powerful chemical dance takes place. Ultraviolet radiation from the sun, a gentle yet energetic force, breaks up carbon dioxide into carbon monoxide and single oxygen atoms. These newly freed atoms then easily react with sulfur dioxide and water vapor, two other trace compounds that make up a minute part of the Venusian atmosphere, to produce the dense sulfuric acid clouds that we see. This is the calm before the storm, the relatively temperate region before the true hellish environment that Venera must soon bravely enter. As you can immediately tell, the true surface of Venus cannot be seen through the planet's thick, obscuring cloud cover. It's like trying to glimpse the bottom of a vast, milky ocean from the surface. So Venera, our quiet pioneer, had to go in blind, trusting its instruments to guide it through the unseen. That same thick cloud cover, acts like a colossal cosmic mirror, reflecting around 3/4 of the sunlight that hits Venus back into space. The ice crystals formed from the sulfuric acid suspended in the atmosphere are incredibly reflective, shimmering with a profound brilliance. This high reflectivity goes a long way towards explaining how incredibly bright Venus appears, both to satellites gently passing by and to observers on Earth, where it stands out as the second brightest object in our night sky, a dazzling yet enigmatic beacon. When we gaze upon those mustard yellow clouds in the visible spectrum, they appear thick and utterly obscuring, revealing little of what lies beneath their impenetrable veil. However, we with our modern tools possess an advantage that the pioneering Venera did not. We have infrared sensor technology capable of perceiving the universe in wavelengths far beyond what our eyes can see. In the infrared spectrum, things look profoundly different, revealing a hidden landscape of heat and subtle atmospheric variations. An image taken by the JAXA spacecraft Akatsuki, for instance, throws things into much sharper relief, showing clear light and dark spots and bands, gracefully wrapping around Venus's atmosphere. And it is here in the infrared that we see the thick carbon dioxide composition of the atmosphere very clearly indeed. Carbon dioxide, as we understand, is an incredibly effective greenhouse gas, a silent, powerful blanket that traps the heat derived from the sun. This leads to an incredibly high surface and atmospheric temperature, a scorching inferno lurking beneath the clouds. Under the gentle scope of infrared observation, this reality becomes strikingly apparent as the entire surface glows under the immense heat generated by the thick layer of carbon dioxide, like a hidden furnace radiating its warmth. The dark patches and stripes that we observe are the previously mentioned clouds of sulfuric acid, floating high above the much brighter, thicker, and intensely hot carbon dioxide layer near the surface. Can you even begin to imagine what Venera would have quietly experienced as it traveled through this hellish realm? Sulfuric acid would have assaulted its outer casing, a relentless corrosive embrace. Winds would have blown at a staggering 100 meters per second, a velocity 60 times the rotation speed of the planet itself. Fast enough to circumnavigate the entire planet in just 4 days, a furious unseen current. The temperature, which at an altitude of 50 to 55 kilometers is anywhere between 25 to 75 degrees Celsius, would sharply rise as Venera descended, reaching blistering levels that defy easy comprehension. The surface air pressure on Venus is equally crushing, a profound weight, equivalent to 75 to 100 times what you'd find on Earth. Comparably, it's like having an entire car sitting gently on your thumbnail, a silent, immense burden. But as Venera descends further, pushing beyond the bottom of the sulfuric acid cloud deck, even weirder, more alien conditions can be found. It arrives once again in what appears to be clean air, free of the dense sulfuric clouds. But things here are profoundly strange. The pressure, this immense crushing force, is now so great that it's starting to have a profound effect on the carbon dioxide in the atmosphere itself. The density of carbon dioxide at this level is so incredibly high that it no longer acts purely as a gas, as we typically understand it. Instead, it behaves more as a kind of supercritical fluid, a fascinating state of matter somewhere between liquid and gas, where a substance gracefully takes on some of the characteristics of both. Imagine air so dense it feels like wading through water, yet it remains a gas. The winds, which roared so fiercely in the upper clouds, now slow down dramatically here, moving at little more than 5 kilometers per hour. The atmosphere below is so thick that it would feel like wading through a very dense liquid with a slow but inexorable current, albeit in a river that is a scorching 464 degree, hot enough to melt lead. It's a quiet, profound transformation of matter, a silent testament to the extreme conditions that define this enigmatic world. But what can modern technology tell us of these layers, beyond the brave initial whispers of Venera? To further illustrate the vast, incredible heat at this altitude level on Venus, Let us gently look at a picture of the lower atmosphere of Venus, taken in the near-infrared range, specifically at a wavelength of 2.3 micrometers by the Galileo satellite. In this image, the red-hot areas of the lower atmosphere are clearly visible, glowing with an intense, silent heat. Also apparent are the darker patches caused by the clouds of sulfuric acid, which are higher in the atmosphere, casting their spectral shadows. This reveals that the lower reaches of the Venusian atmosphere are incredibly hot, and that there are distinct layers within that atmosphere, each profoundly different in both temperature and composition, like a celestial onion peeled back layer by gentle layer. To further demonstrate the subtle yet profound differences between the atmospheric layers of Venus, let us now cast our gaze upon the layers we've seen so far, but this time under ultraviolet light. While the images again from the JAXA spacecraft Akatsuki taken in the 283 and 365 nanometer wavelengths do not show as much contrast in color and brightness, as the infrared images they do reveal more variance than ones viewed in visible light. The areas of darkness and blotchiness within the cloud layers indicate that ultraviolet light is being absorbed rather than reflected. But exactly what chemical or combination of chemicals causes this mysterious absorption is still a matter of quiet debate among the astronomy community. Clearly, there are elements and compounds within the Venusian atmosphere that still gently evade our attempts to fully discover and categorize them. Holding their secrets close, and on the subject of Venus's atmosphere, defying easy explanation. Let's consider a remarkable phenomenon seen at its poles. If you look at Venus's poles in the infrared, do you notice anything strange about them? Present at both Venus's north and south poles are large polar vortices, vast swirling atmospheric phenomena, each about the size of Europe, whipped up by those immense 100 meter per second winds we discussed earlier. What's truly weird, though, is that they have not just one central eye, like a terrestrial hurricane, but two. And scientists are still not quite sure why a quiet, persistent mystery. Venus's complex, highly variable polar vortices are extremely hard to model, as they can change on timescales of less than 24 hours, making them quite the enigma, a restless, unpredictable dance in the planet's upper atmosphere. But once it had bravely passed through the enigmatic atmosphere, what did Venera actually see down there on the surface? Let us conclude our gentle journey through the thick, acidic clouds and finally arrive at the surface of our closest companion. We earlier glimpsed the very first image ever sent from the surface of Venus, a grainy yet profound testament to human ingenuity. Due to the massive, suffocating cloud of sulfuric acid obscuring any kind of view from space, the only images of Venus that show the surface in visible light are those that have been taken from a lander directly on the surface, and of those we only have 6 precious images taken from 4 of the Soviet Venera probes that successfully landed, such as our pioneering Venera 7. The air surprisingly was clear. Scientists had wondered whether everything would be obscured by a thick, soupy haze. But this didn't appear to be the case. Everything, however, was bathed in a dull yellow hue, the pervasive color of the acidic composition of the atmosphere. And while we might be surprised to find solid rocky ground under the thick, crushing air of Venus, that ground itself was utterly desolate, hinting at ancient lava flows now hardened into flat plains, gently eroded under Venus's intense, corrosive atmosphere. Everything seemed profoundly dry, which is unsurprising given the baking heat. Perhaps a billion years into the future, when the sun has increased its luminosity enough, we might see similar runaway greenhouse effects and similar stark results on Earth, a quiet cautionary tale from our cosmic neighbor. But here with Venera 7, we must leave this brave little probe. The Venera series of probes, including the one whose journey we have been following, never lasted more than a couple of hours on Venus's surface, a fleeting existence due to the unforgiving combination of extreme heat and crushing pressure. Their images, though brief, gave us a vital glimpse into the conditions down there on the rocky ground, a silent snapshot of a hellish world. But although these 40-year-old images are the only cases of photographs being sent directly from the planet's surface, there is another profound way we can learn about the geography and topography of Venus seeing through its dense veil. It's not infrared or ultraviolet. Neither of these imaging techniques can pierce through the thick cloudy atmosphere to clearly see and map the surface with any kind of clarity. You need something entirely different, something that can penetrate the unseen. Step forward, radar imaging. The USSR began the process of using radar to map the surface of Venus with their later Venera models, 15 and 16, in 1983. These missions produced images with a resolution of 1 to 2 kilometers on the ground, a significant step in understanding the hidden landscape. This capability was dramatically improved upon roughly a decade later with the NASA Magellan probe, which between 1990 and 1994 managed to map around 98% of the Venusian surface with an astounding resolution of 120 meters. The images produced using this radar data are truly spectacular, revealing a world of colossal volcanic activity, vast silent lava flows, and massive cratering. The surface, geologically speaking, appears reasonably young, possibly as a consequence of the intense volcanic activity resulting in truly vast lava flows that periodically resurface the planet. A composite image of the surface meticulously created from data gleaned from the Venera Pioneer and Magellan missions looks truly magnificent. Surface details from immense volcanoes to deep valleys, from impact craters to winding chasms, are shown in clear relief, their forms etched by ancient powerful forces. The remarkable utility of radar imaging to pierce the thick, obscuring clouds and show us what truly lies on the surface of Venus has greatly boosted our knowledge about the planet, unveiling its hidden beauty. And isn't the hidden beauty of it all revealed through these silent radio waves? Truly remarkable. So, with all we now know about our nearest planetary neighbor, what remains to be discovered from Venus in the future? The answer is a lot. In recent times, by far the biggest news regarding Venus has been the discovery, or perhaps the intriguing non-discovery, of the gas phosphine high in the Venusian atmosphere. In 2020, measurements from the James Clerk Maxwell Telescope indicated the possible presence of trace amounts of this enigmatic gas. Phosphine is produced through a variety of different processes, but one of those, and the one that gently excited everyone, is through microbes living in low oxygen environments. Imagine for a moment life in one of the most unlikely, hellish places imaginable. What a profound outcome that would be. However, subsequent studies found no such phosphine again, and by 2022, the initial idea of it being present in the Venusian atmosphere had been quietly dismissed by NASA. It would have appeared that the findings of the initial study were in error. But then Professor Jane Greaves of the University of Cardiff went on record at a prestigious meeting in 2023, stating that the JCMT had found phosphine once again, this time deeper within the atmosphere of Venus. Hopefully, future missions will give us a definitive answer to this truly tantalizing question, this quiet whisper of potential life. Many other profound questions await answers too. Why, for instance, did two planets, Venus and Earth, so similar in size, evolve so dramatically differently? Was there, in fact, liquid water on Venus's surface once upon a time, flowing freely before the Great Transformation? What is a more accurate picture of the chemical composition of both the Venusian atmosphere and its surface that might help answer these persistent conundrums? After decades of being relatively overlooked in favor of Earth orbit assignments and outer planetary probes, Venus has suddenly garnered a renewed quiet interest. Several new missions are planned for Venus within the next 10 years. These missions originate from the USA, ESA, Russia, China, India, and even one ambitious private American venture, the Venus Life Finder. With any luck, one more or all of them will lead us on a voyage of great discovery about our beloved star of the morning and evening, gently divulging a wealth of information and answering some of our burning questions about Venus, painting an ever clearer portrait of this enigmatic world. So, there you have it. Looking at Venus through a variety of differing wavelengths beyond what our eyes can see has given us far more profound knowledge than visible light alone could provide. We have been able to discern immense volcano and crater formations through kilometers of opaque clouds, like seeing through a heavy curtain. We've begun to determine some of the intricate chemical composition of both the Venusian atmosphere and its surface, unraveling its very building blocks. And we've used infrared imaging to make the invisible visible to us all, revealing the hidden warmth and atmospheric dance. All of these quiet achievements have granted us precious hints as to why the conditions on Venus are so extreme, so profoundly different from our own home. And just maybe they hold the quiet possibility, however slim, of simple microbial life on our closest neighbor. It is a story still being written, a silent, profound narrative of discovery. Let us now shift our perspective and observe a different kind of cosmic ambition, one that speaks of a rapid and determined ascent. In April 2021, the Director of National Intelligence produced a quiet but impactful report, claiming that within 3 decades, another country was on course to match or even exceed the US as a world-class space leader. And even by 2030, that other country would probably achieve world-class status in all but a few space technologies. You might already be whispering its name, China. There are plenty of compelling reasons to believe this might indeed be the case, a gentle shifting of the celestial scales. China's economy over the last 50 years has undergone a profound and rapid transformation, quietly catching up to that of America's. Some astute analysts are even predicting it will quietly overtake the US by 2035. And while the United States currently holds a significant lead in space expenditure, China is firmly in second place and is achieving some technically very impressive things, even with a comparatively smaller budget. You might have already heard the quiet news that China has landed a rover on Mars, making them only the second nation ever to achieve this delicate feat. They also became the first to successfully send another rover to the far side of the Moon, a truly pioneering endeavor into uncharted lunar territory. But China's ambitions, one quickly realizes, do not end there. So what are the goals and aims of this rising nation? This new star in the spacefaring constellation? What has China already achieved and witnessed so far in space? Where do China's leaders quietly hope for their space program to be in 1050 or even 100 years from now? And what pioneering projects are Chinese scientists quietly working on that have led American analysts to worry that NASA's long-held lead is rapidly eroding? Let us take a closer, more contemplative look at the US's biggest rival in the modern space race and gently contemplate what the future might hold based on China's ambitious plans for our solar system. To begin with, China was not always a great space power. Back when Mao Zedong declared the official formation of the People's Republic of China in 1949, the country as a whole simply did not possess the industrial capacity to keep pace with the likes of America and the USSR. So around the time the Soviet Union quietly kickstarted the first space race in the mid-1950s, China's Communist Party recognized the profound need to attempt to revolutionize their largely agricultural nation into something more modern, more industrially robust. However, their ambitious Great Leap Forward tragically turned into a great leap backwards, as farmers were uprooted from their private farms and reorganized into communal labor farms and factories. The system proved unable to even produce enough food to match their prior output, leading to a devastating period where 30 to 45 million people died from starvation and execution. China's economy, perhaps unsurprisingly, actually shrank during this time. And things didn't get any better for China's nascent space program during the Cultural Revolution, a tumultuous period during the 1960s and 70s, where Mao encouraged local citizens to ruthlessly remove dissidents and traitors from the general populace and the leadership. Many intellectuals with scientific knowledge were tragically persecuted as bourgeois, leading to widespread abuse and deaths. Between starvation, a weak economy, and the direct attack on knowledge itself, it is no surprise that China's space efforts struggled to get underway, moving with great difficulty. Despite initial Soviet help in the form of scientists and technology, China's first, most basic rocket, the T-7M, didn't get off the ground until 1960. And after a souring of Chinese-Soviet relations soon thereafter, China was left to quietly figure out ballistic missile and space technology largely alone, a solitary journey of trial and error. That was then, and this is now. Thanks to a much more successful economic policy change, gently brought in by Mao's successor, Deng Xiaoping, in 1978, China has undergone a truly remarkable transformation. It has soared from a measly 2.7% of global GDP in 1980 to a whopping 16.9% in 2023. For context, the U.S.'s share has remained fairly stable, shifting from 25.4% in 1980 to 26.1% in 2023. And with this profound growth in economy has come a corresponding quiet growth in expenditure on space. China now allocates the second highest amount in the world to its space programs, a significant investment in its cosmic future. This expenditure has allowed it to complete some truly very impressive projects, quietly establishing itself as a formidable new player in the cosmic arena. In 2004, China announced its formal interest in gently exploring the moon, a renewed focus on our closest celestial neighbor. They launched their first Chang'e probe, beautifully named after the Chinese moon goddess, in 2007 in quiet cooperation with ESA. Chang'e 1 gracefully orbited the moon and meticulously mapped its surface, successfully completing all the objectives China had set for it. But this was far from the end goal. China was patiently laying the groundwork for a more thorough exploration of our closest neighbor, a carefully orchestrated plan unfolding over time. In 2013, Chang'e 3 became the first Chinese probe to achieve a soft landing on the lunar surface, a delicate touchdown that required immense precision, making China the third nation ever to accomplish a landing like this. But China wasn't content with merely being third, so in 2018, they attempted something that had never been done before. A truly bold step, a landing on the far side of the moon. The far side of the moon, perpetually turned away from Earth, is inherently cut off from direct communications with us. This means the only way it's possible to coordinate a landing there is through the aid of an intermediary spacecraft, an orbiting relay that can gently bounce signals. In spite of the challenging nature of this task, Chang'e 4 completed a successful landing, a quiet triumph against daunting odds. And it even brought with it a small biosphere, a tiny self-contained world with seeds, fruit fly eggs, soil and air, all designed to observe how this little mini ecosystem would handle conditions on the moon. Remarkably, some of the seeds actually sprouted, making them the first plants to gently sprout on the moon, although their life was a little short-lived, fading after just a day. Since then, China has completed 2 more Chang'e missions, each one building on the last, adding to their growing understanding of our celestial companion. Both Chang'e 5 and Chang'e 6 successfully collected precious samples from the moon and gracefully brought them home, tangible pieces of lunar history for scientific study. The biosphere experiment, though small, might have offered us a subtle glimpse at China's long-term goals regarding the moon. After all, why practice growing plants on the moon unless you are gently considering how to put down roots there yourself? And indeed, this is China's profound long-term aim. In 2019, China publicly announced its intention to build a research station on the moon. Within the next decade, a grand vision of a permanent human presence, and since then, it has been actively encouraging other countries to gently get on board, fostering a spirit of international collaboration. To date, 13 nations and 2 organizations have already agreed to do so, including Russia, South Africa, Belarus, Pakistan, and Egypt, creating a diverse coalition of spacefaring nations. If this sounds familiar, it's because it bears a striking resemblance to what the US is doing with the Artemis Accords gathering nations to share in the benefits of space exploration together. Indeed, state media often quietly compare the International Lunar Research Station ILRS and the Artemis Accords as rival projects, although China does not seem eager for them to be viewed as such, preferring a more collaborative narrative. China has formally invited the US and Europe to take part in the ILRS, extending a quiet open hand. Although the US might not agree due to existing American laws that prohibit China-US partnership on space projects, it's possible that other European countries will choose to do so. This wouldn't be the first time ESA and China have collaborated on space missions, demonstrating a precedent for quiet cooperation. As a gentle side note, it was only recently in 2011 that America passed the Wolf Amendment, which specifically prohibited collaboration between America and China without direct congressional approval. The US was quietly worried that China was learning too much from US rocket technology. They didn't want China to get to places like the moon before them. By piggybacking off their technology, a subtle undercurrent of caution and competition. China's eyes, however, turn further than just the moon. Just like the US, China has been quietly considering exploring other planets in the solar system. In February 2021, China's Tianwen-1 mission, meaning questioning the heavens, successfully entered Mars orbit, a significant achievement. It gracefully consisted of 2 parts, an orbiter and a rover named Zhurong, which landed a month later on the Martian surface. This delicate landing made China only the second country ever to successfully land a rover on Mars. Zhurong patiently spent about a year on Mars, using its radar instruments to meticulously map out subsurface water, listening for hidden reservoirs. It even had a camera similar to NASA's Perseverance rover, capable of gently zapping rocks to better understand their chemical composition, a precise way to unravel geological secrets. Once again, though, this was just groundwork. China intends to return precious samples from Mars' surface to Earth by 2031, which, if achieved, would be about a decade ahead of NASA's own sample return plans, which are currently still very much in the development stage. Retrieving samples from Mars for study would be a tremendous boon for scientific research, as Earth's scientific equipment is much more advanced and precise than anything you can fit on a rover. And it will undeniably be a distinct advantage for a nation quietly considering how best to build permanent structures on Mars, as they consider materials they might be able to source directly on site, a gentle step towards sustainable off-world living. A key to all these grand ambitions is China having a strong enough launch vehicle, a powerful and reliable workhorse for its cosmic dreams. Whether it's transporting base components to the moon or Mars, having a powerful, cost-effective, and preferably reusable rocket will gently open up the heavens to China's ambitions. It should come as no surprise to you that such a rocket is well underway. The Long March 9 will be a super heavy variant of the Long March series, aiming to carry payloads of up to 150,000 kilos into low Earth orbit. If this number sounds familiar, it's because it's remarkably similar to what SpaceX's Starship is aiming to achieve, a quiet convergence of engineering ambition. The rockets are similar in more ways than one. Long March 9 will in time become a reusable rocket, although initial versions expected to be ready by around 2033 will only be for single use. The profound savings this provides is a game changer for any deep space construction projects China hopes to complete. An average Long March rocket currently costs about $3,000 per kilogram to get mass into orbit. The reusable nature of the Long March 9 could gently drop this to as low as $1,500 effectively, cutting their launch costs in half, making the vastness of space a little more accessible. And China indeed has other deep space construction projects, a grand vision quietly unfolding. China has its own permanent space station, the Tiangong, or Heavenly Palace, a testament to its independent capabilities. It is a smaller space station than the ISS, only able to house 3 astronauts in its 3-module setup compared to the ISS's 7 astronauts in 18 modules. but it still remains an impressive feat of engineering and physics, a floating home in the silent expanse. The space station's primary core was launched in 2021, with two earlier generations tested in 2011 and 2016, a patient evolution of design. Tiangong has been the home of many Chinese astronauts or taikonauts and has facilitated numerous spacewalks. It also shares an orbit with the Shuntian Space Telescope, making it a convenient staging point for any repairs the telescope might gently need. China wanted its own station, partly because China was excluded from the International Space Station, again due to U.S. law prohibiting China and the U.S. from working together when it comes to space, for fear of China stealing technological secrets. For the record, NASA and Chinese scientists are much more in favor of cooperating. For instance, when China retrieved samples from the moon, NASA quietly petitioned Congress to allow them to take a look at what China found. China itself was more than happy to share. Building international goodwill seems a core part of its long-term space aims. China's space station is similarly open to other nations for conducting scientific experiments, an open invitation to share the wonders of space. And although no other nations have as yet visited the smaller 3-module space station, 9 different international scientific projects from 17 different countries have been agreed upon, including participation by UN members. Again, scientists generally do not mind what country other scientists are from, as long as they have a good chance to do good science together. It tends to be governments that do not entirely trust other governments' motivations. Though perhaps this is for good reason, a gentle undercurrent of geopolitical complexity. All of this paints a fascinating picture of China's long-term aims, a profound desire to explore and set up permanent bases across the solar system. And indeed, if you look at China's long-term plan projects, you can see this vision gently take shape. China aims to send probes to explore Jupiter and its environs, aiming to launch in 2030, reaching for the distant gas giant. It wants to launch 40,000 satellites around Earth, to significantly improve its satellite coverage and its ability to compete with the likes of Starlink, a vast network of silent observers. And Chinese scientists have even proposed a long-term plan for developing resource collection and logistics supply chains across the entire solar system, a grand multi-generational vision to be completed somewhere by 2100. This is not an official government plan, but it's a fascinating insight into what China might be quietly considering in the future. The plan gently talks of asteroid mining, using water ice found there for fuel supply nodes and logistics chains spanning across the solar system. In the long term, China is considering how to get the most out of space while outwardly cooperating with international partners. As it does so, a delicate balance of ambition and collaboration. So will China get ahead of the US when it comes to these kinds of aims? That's one potential scenario, and it's certainly what US intelligence analysts were quietly worrying about when they wrote that D&I paper in 2021. But there are 2 other futures that also seem possible as things stand. The US still spends more than China on space by a wide margin, $73.2 billion, compared to China's $14.5 billion. This means the US spends more on space programs than every other country in the world combined. So although China is second on this list, NASA's lead is not currently that much under threat. As long as this sort of discrepancy remains the same, it seems unlikely that China will entirely overtake the US, even if some Chinese projects are quietly getting ahead of NASA ones. Overall, the US is still learning more about space and will likely remain dominant in that area for quite some time. Then again, China's budget size could be misleading. China can complete its projects much cheaper than the US, thanks to its more economical manpower, particularly if it's willing to cut corners on safety, a subtle distinction in cost-effectiveness. But perhaps the most beautiful outcome, the most peaceful vision, is that it stops being quite so much a competition in the years ahead. As nations begin to have not just the odd space station or research outposts outside of Earth's orbit, but a more widespread presence, it will become increasingly necessary to have some kind of common rule that all nations abide by. This cosmic rule book would gently detail the rights of certain nations and organizations to the resources scattered across the solar system. Rather than having the US and China form two rival camps of nations, hopefully in time we can have one common rulebook that both nations are playing by a shared understanding for the vast frontier. I fully expect both nations to continue in their efforts to outdo each other within that framework. Competition seems to be human nature after all, and neither China nor the US seem to be above it. But at least it should be done with the quiet understanding that they can sometimes work collaboratively as well as in rivalry. That's the only way space will truly be, for everyone, a shared inheritance. The US is not the only big fish swimming in these waters. 100 years from now, the map of the solar system will not just be covered in red, white, and blue flags, but will also be home to many that are red, with 5 stars, a tapestry of nations reaching for the cosmos. This is a quiet narrative of a future unfolding one where the stars might embrace many different banners all under a shared sky. Let us now return our gaze to our closest celestial neighbor, the Moon, and consider the ongoing meticulous efforts to map its intricate face. The Lunar Reconnaissance Orbiter, or LRO, launched by NASA in 2009, has been silently circling the Moon from an altitude as low as 50 kilometers from its surface. Since then, a vigilant eye patiently studying every contour. Its initial mission was to map out the Moon's surface in hitherto unmatched detail, like a tireless cartographer meticulously tracing every line. When this remarkable feat was achieved after just 1 year, NASA, with thoughtful adaptability, shifted LRO's mission to investigate areas of particular scientific interest, to probe deeper into the Moon's subtle mysteries. We have spoken in previous whispers of the highest and lowest points on the Moon, as well as vast basins and truly impressive impact craters. But these are not the things of greatest value to future explorers. In fact, one of the most important features on the Moon, a quiet revelation, is a humble hole in the ground. This is a pit crater, a remarkable depression that tells a hidden story. By carefully evaluating the shadows cast within it, scientists can gently discern its immense scale. It's a massive 100 meters deep and between 100 to 115 meters across, depending on where one measures its sheer dramatic edge. Unlike impact craters, which are formed from the forceful explosive kiss of space debris crashing down onto the Moon's surface, it is thought that pit craters like this one are formed by a cavity collapsing deep underground. Imagine a hollow space beneath the surface slowly giving way, causing the ground above to gently subside. This process is strikingly similar to how sinkholes form here on Earth, albeit on a grander cosmic scale. This provides further tantalizing proof that under the silent surface of the Moon, there may exist intricate networks of caves and vents, perhaps formed by rivers of flowing lava. Long, long ago, the Moon is cold now, its ancient volcanic heart largely stilled, so these lava tubes would lie empty, silent, waiting. But this possibility presents astronauts and scientists with a unique, profound opportunity. If they do indeed exist, it's incredibly likely that these lava tubes would provide a remarkable, easily accessible record of the geological processes that shaped the Moon, like an ancient library carved into stone. They might even be coated in interesting and rare minerals, hidden treasures waiting to be discovered. On top of that, it's infinitely much easier to set up a base on the Moon if your walls and ceiling are already formed for you, a natural shelter provided by the Moon itself. This natural shelter is not just convenient, it's vital for survival. Lacking a global magnetic field or any real atmosphere, the surface of the Moon is completely exposed to the relentless bombardment of solar and cosmic radiation. Over time, this constant stream of high-energy particles could deliver a lethal dose to any would-be settlers, a silent, invisible threat. The only way to reliably avoid this would be to line your buildings with thick, heavy materials to block out the radiation, a cumbersome and resource-intensive task. But 100 meters of solid rock provided by an ancient lava tube would do the same job just fine a natural profound shield. If pit craters truly provide a gateway to such cave systems 100 meters deep, astronauts may well quietly pick out a site, much like this one, to settle on the lunar surface, a gentle return to the concept of living beneath the Earth, but on a different world. Of course, any would-be settler on the moon will not just need protection from radiation to survive. They will also need access to water, the very essence of life. And it is here that LRO has provided some more fascinating insights into the moon's subtle surface processes. It was once thought that the surface of the moon was utterly dead and dry, a parched, lifeless sphere. If water existed at all, it was believed to be found only in small precious pockets, hidden away in permanently shadowed regions, like tiny frozen oases. However, as LRO gracefully traveled over the lunar surface, it began to notice something unexpected, something truly remarkable. Faint, tantalizing trace amounts of water molecules could be found softly clinging over the top of the surface, regolith, the gray powdery rock that makes up much of the moon. It turns out, to our quiet surprise, that the moon is ever so slightly wet, a subtle, widespread dampness. This unexpected wetness was even observed to gently move around in a sort of lunar water cycle, a quiet, continuous dance. This movement was observed both by region and by time of day. Around noon, when the moon's surface was hottest under the relentless sun, the water seemed to dissipate, subtly evaporating into the thin lunar exosphere. But then, with the gentle approach of evening, it would quietly return, perhaps condensing from the faint wisps of atmosphere or migrating from shadowed areas. Scientists do not yet fully understand everything about this intriguing process. Where did this water come from in the first place? Why did it not all evaporate irrevocably into space long ago? But LRO's profound observation means that the locations on the moon that might be viable for a lunar base are suddenly much, much wider. If this trace amount of water could be collected and utilized, future settlers would not need to painstakingly build their base right next to a permanently shadowed region, which is convenient, as these PSRs are far colder than we at first thought, holding their own icy secrets. The moon, in its majestic cosmic dance, has very little axial tilt, a mere wobble of a little over a single degree. This subtle tilt means that at the poles there exist craters that are never pointed directly at the sun, regardless of the time of day or year. These are permanently shadowed regions, PSRs, pockets of eternal twilight. The sun's gentle light never casts its warmth into their mysterious basins. Naturally, a location that never sees any sunlight is bound to be cold, profoundly so. However, scientists were not fully prepared for exactly how cold it turned out these regions truly were. For context, at the equator, temperatures on the moon fluctuate wildly between a scorching 120-degree Celsius during the lunar day and a bone-chilling minus 130-degree Celsius during the long lunar night. LRO houses a sophisticated diviner instrument which uses 7 thermal infrared channels to meticulously measure surface temperatures. With it, LRO found a polar crater that had temperatures as low as 250 degrees Celsius, making it the coldest temperature measured on any object in the entire solar system, even colder than the average temperatures of distant Uranus-Neptune, or even Pluto, our quiet icy dwarf planet. The crater edges like silent guardians, shielding these areas from direct solar radiation, might have created the perfect storage location for housing not just water ice, but other more interesting, potentially useful compounds: carbon dioxide, carbon monoxide, dinitrogen, and argon. Perhaps these compounds, frozen solid in the eternal cold, could be invaluable for future settlers, providing resources for breathing air fuel or building materials. And so, accessing these materials might be extremely useful in spite of the chilling cold. But because it's so profoundly dark down in these craters, it's difficult to know for sure exactly which craters house what precious compounds. It would be quite unfortunate to build a scientific base only to discover, after immense effort, that the crater next to you was completely empty, a silent disappointment. Sadly, LRO's onboard camera, while powerful, is not capable of piercing this absolute darkness of seeing into these veiled depths. But there is a new camera gently circling the moon that can. The reason why I mentioned earlier that 6 countries had successfully sent probes to the moon before December 2022 is that on December 16th of that year, that number actually rose to 7, with a quiet new contender joining the lunar exploration. After a 4.5-month journey, South Korea's Danuri probe just arrived in lunar orbit, a graceful new addition to the cosmic ballet. NASA has actually been working closely with South Korea on Danuri, providing them with invaluable scientific expertise and crucial communications and navigation support, all in a spirit of mutual international scientific collaboration. In a gesture of profound thanks, South Korea's KARI space program gently gave NASA 7 kilograms of precious space on their Korea Pathfinder lunar orbiter, or Danuri, as it's locally known. A beautiful composite word made from dael, meaning moon, and nuri, meaning enjoy. NASA carefully considered what scientific instrument could be best placed on Danuri, a delicate choice for a precious opportunity. In the end, they went with a device known as ShadowCam, a younger sibling of LRO's own narrow-angle camera, but with one notable profound enhancement. Thanks to its 200 times greater sensitivity, ShadowCam can transform images like those taken by LRO in deep shadow into images of incredible clarity. Imagine peering into profound darkness, and suddenly, gently, the unseen is revealed. This incredibly clear image, for instance, is of Shackleton crater found at the moon's south pole, the very first site photographed by LRO. And now, thanks to Danuri and its ShadowCam, we can properly intimately peer into its inner basin, a detailed glimpse into eternal shadow. It turns out that Shackleton, when viewed with this new profound clarity, does not look remarkably different from many of the other craters on the moon. Its cratered floor is covered in bumpy hummocks, like a gently uneven terrain. Sadly, there is no obvious glistening ice here, no vast deposits revealed. Perhaps this is because Shackleton is a smaller crater, meaning that the temperatures within do not drop quite so low as would be needed for ice to reliably form and persist. One point of quiet interest, however, is the clear trail left by a boulder as it slowly rolled down the crater side, visible near the top of the image, like a faint ancient path. Such tracks are common on the moon, a poignant reminder that the lack of wind means that any disturbance of the dusty ground is never covered up again. This track, seemingly fresh, could be incredibly old, a silent record of a rolling rock from countless millennia ago. This is the only image released by ShadowCam so far, a single precious window into a previously hidden world. However, Danuri intends to orbit the moon for the next year at least, and in that time, it will hopefully drive back the shadows on all of the moon's hidden terrain, revealing countless more secrets. So there you have it. Thanks to the LRO, and now, with the gentle assistance of Danuri, the surface of the moon is being mapped in clearer and clearer detail, like an intricate tapestry, slowly being unfurled before our eyes. Processes, such as the lunar water cycle, this quiet ethereal movement of water molecules, are being understood, more deeply unraveling a subtle dynamic side of our seemingly inert neighbor. And the way is being patiently paved for future missions to actually land on the moon. Not blindly, but with exquisite knowledge of their chosen destination. This knowledge is crucial for the discovery of compounds vital to human life, the very building blocks for a sustainable presence beyond Earth. And that's not even mentioning the developing scientific understanding of the origins and history of the moon that is gently coming about as we uncover its geological record, like reading an ancient powerful book. When scientists one day arrive on the moon to study this record firsthand, to touch its ancient rocks, it will be thanks to this meticulously collected data that they will know precisely where to go, guided by the silent whispers of our orbiters. As the number of nations settling on the moon increases, as humanity spreads its gentle touch across the cosmos, they will rely more and more on LRO and Danuri's information to know where to construct their outposts, to find their safe havens. That's what excites me most about all this, the profound, quiet promise it holds. We are metaphorically brick by gentle brick, laying the very foundation for possible future civilizations. Thanks to the wealth of knowledge being developed by these orbiters and pathfinders, one day millions of humans might just call the moon by another name home. It is a future being quietly built, one data point at a time, a testament to enduring curiosity and gentle persistence. Let us now conclude our gentle exploration of humanity's quiet reach for the stars by considering a final poignant story, one that highlights the enduring universal nature of curiosity. When you think of the space race, your mind probably conjures images of the tense Cold War-era battle between the United States and the Soviet Union, a grand, thunderous competition. But what if I were to whisper to you that there was another player in the game, a quiet, unexpected participant? While the superpowers wrestled for space dominance, a small and newly independent nation, far removed from the global spotlight, started developing its own ambitions of reaching the stars, of perhaps even beating the big dogs to it. The story of Zambia's space program is a beautiful example of humanity's overpowering curiosity to explore and understand the cosmos, a desire that knows no geographical bounds, no matter where we're from and how far we're willing to go to do so. It's also a gentle reminder that history is often shaped by those who get to tell it, and it isn't only the loudest voices that leave the biggest legacies. Join me now as we dive into this little-known story of the Zambian space program, their proposed mission, unconventional training practices, and the lasting impact of their leader's unique vision. After World War II, a new global order began to emerge, and the US and the Soviet Union, having tasted the bitter fruits of conflict, realized that in a world now armed with nuclear weapons, there could realistically be only one superpower. They entered a bitter, quiet struggle for dominance, each racing to stay one step ahead of the other, engineering increasingly powerful rocketry and weapons technology. It didn't take long for their arms race to quietly morph into a space race, a new arena for their simmering rivalry. By the early 1960s, new milestones in space exploration were being made every year, each one celebrated with a quiet fervor. Both programs enjoyed unwavering political and public support, which translated into abundant funding, widespread press coverage, and rapid progress. All eyes were on them, their every move watched intently, and the stakes were incredibly high. Half a world away, Edward Mukuka Nkoloso was watching too. He was a passionate science schoolteacher in Zambia, a man whose heart swelled with a quiet, boundless curiosity. He dreamed of one day creating his own Zambian space program, one that could truly rival those of the Americans and Soviets, a bold, almost unimaginable ambition for his young nation. The only immediate problem: his country was grappling with its own profound political struggle, the arduous fight for independence. Zambia, then known as Northern Rhodesia, had been under British colonial rule since 1888, a long period of quiet subjugation. Through the 1950s, Zambians grew increasingly disillusioned with colonialist policies such as racial discrimination and the limited political representation afforded to Africans. Nkoloso was one of these passionate Africans. After bravely fighting in World War II on behalf of Britain, he returned home and, with a gentle spirit of defiance, opened a school specifically for Zambians. This school, however, was promptly shut down by the British authorities, a quiet act of suppression. This setback only fueled his determination, pushing him to join the Zambian resistance movement, and later, the United National Independence Party, both dedicated to the cause of freedom. Nkoloso, a man of profound dual passions, worked tirelessly for both causes close to his heart. While on one hand, he was fighting for Zambian independence, a battle for self-determination, the other hand was quietly, meticulously building the Zambia National Academy of Science, Space Research, and Philosophy, which bravely opened its doors in 1960. The exact details of what transpired at his academy are somewhat murky, shrouded in the mists of time. But it seems this is where Ankoloso's audacious idea for a Zambian space mission truly emerged. He declared with quiet conviction that he was going to send Zambian astronauts, or Afronauts, as he affectionately called them, to the moon, and then even more incredibly to Mars. And he was going to do it, he insisted, before the mighty US or the Soviet Union could achieve such a feat. We have been studying the planet through telescopes at our headquarters and are now certain Mars is populated by primitive natives. He announced, his voice ringing with a quiet, earnest belief. Specially trained space girl, Mata Mwamba, 2 cats also specially trained, and a missionary will be launched in our first rocket, he added with a twinkle in his eye. But I have warned the missionary he must not force Christianity on the people of Mars if they do not want it. If you're gently wondering about the cats, they were included partly for companionship for Mata, but also partly as a survival testing device. Mata was instructed to gently throw one out onto the Martian surface upon arrival. If it survived, she would know it was safe for her to emerge too. In 1964, Ankoloso, with a profound sense of readiness, announced his mission was complete. The first rocket was planned to launch on Zambia's Independence Day, October 24, 1964. Now going up into space is never an easy task. One must be in tip-top physical and mental shape to be an astronaut. In the early days of the space age, some training exercises were grueling, even downright dangerous. In the 1960s, Soviet cosmonauts were undergoing all kinds of rigorous physical training and conditioning. For instance, they were often put in a centrifuge to recreate the intense G-forces of launch, an incredibly dangerous simulation that puts immense strain on the heart and lungs. Such training could lead to oxygen starvation and cause trainees to pass out. It also limits the ability of your heart to pump blood upwards against gravity to your brain and other vital organs. Long-term exposure to multiple G-forces can lead to complications like arrhythmia. Over time, cosmonauts also underwent parabolic flights for weightlessness training. Named for the parabolic flight path the aircraft follows. At the top of the curve, the acceleration of the aircraft cancels out the acceleration due to gravity, achieving a feeling of momentary weightlessness for the passengers. It's kind of like when you're on a swing, and at the highest point of your swing, you feel weightless for just a moment, except in an aircraft with the right trajectory. You can feel that microgravity for up to 40 seconds. While effective, these flights were risky due to the high potential for mechanical failure or pilot error, as only the most skilled pilots at the time could pull off the precise maneuvers needed. Cosmonauts also had to be prepared to confront an incredibly harsh environment in the event their mission might land far from recovery zones. Wilderness survival training in Siberia was an essential part of mission training, which sounds absolutely brutal. Even in modern times, the lengths some will go through to reach out for space can be quite perilous. Daredevil Mike Hughes tragically discovered that after constructing his own homemade rocket in an attempt to prove his belief that the Earth is flat. In February 2020, his rocket malfunctioned during a test flight, killing him instantly. While no one died in the Zambia space program, its training definitely raised some eyebrows, and Ankoloso, with his unique vision, designed a series of mental and physical tests to prepare his astronauts for space travel, a truly unconventional approach. One such exercise involved teaching his recruits to walk on their hands with Ankoloso, calmly claiming that this was the only way people could walk on the moon. It's unclear where that idea came from, especially since he was an educated man and was presumably following the latest space race updates closely. To simulate zero gravity, he would put his recruits in an oil barrel one by one and gently roll them down a hill, bouncing them over rough ground to simulate turbulence. When they hit a particularly big bump, he would celebrate gleefully, claiming they had just experienced anti-gravity conditions. This exercise, while certainly uncomfortable and potentially dangerous, was definitely not scientifically sound, a stark contrast to the rigorous methods of the major powers. Another approach they took to weightlessness training actually involved something I mentioned earlier, a surprisingly simple method. They would tie 2 ropes to a swing and with enthusiastic pushes would swing higher and higher. At the time they least expected it, another trainee would bravely cut the rope so they could experience the free fall to the ground. Not a much better approach, one might gently surmise, but a testament to their resourcefulness and the rocket ship they were training for. It was a 10-foot oil barrel with an air hole in it, quaintly described as being made of space-grade aluminum and copper. And care to know how they were initially planning to launch it? With a catapult. His willing recruits were a group of 12 teenagers he was training at the space program's headquarters, a secret location 7 miles outside of Lusaka at an abandoned farmhouse. Madamwamba, the young girl who was supposed to actually fly the mission, was just 16 years old at the time. NASA had ex-military Air Force pilots and engineers in state-of-the-art purpose-built facilities, and Encoloso had a dozen high school children in a field. Now I know it seems like I'm making this up, but this truly happened. As absurd as it all sounds, there's a quiet, profound mystery about Encoloso himself. He was, by all accounts, an intelligent guy. He read extensively about space. He was a science teacher, a veteran, and a valued member of the political movement that led to the nation's independence. So, what was his end game? Why was he talking about this mission if he must have known it wasn't viable? Some have quietly speculated that his motivation to join the space race came from a deep place of national pride and an earnest desire to elevate not just Zambia, but all of Africa to the world stage. He was seen as working to gently dismantle stereotypes about Africans that had held steady during the colonial era, and instead to quietly show that Africans are capable of contributing to scientific and technological advancements, that brilliance knows no geographical bounds. If his goal was to get the international press talking, he certainly succeeded. Time magazine ran an article about him, as did several other outlets. News crews went out to film video interviews with him and record his team training. His colorful personality and outlandish claims definitely helped capture public imagination and media curiosity, even if it wasn't always clear if he were truly serious or not. Encoloso himself maintained he was serious until his death in 1989. When asked about it in 2016, the first president of Zambia, Kenneth Kaunda, gently suggested it wasn't a real thing. It was more for fun than anything else. There's another theory, a quiet murmur that his whole project was a subtle satire, a parody of the Western conquest of other nations. There didn't seem to be a reason for such goofy-looking training exercises other than to capture people's attention. Even during his interviews, he always stayed in character with his standard issue helmet and flowing cape. But he'd throw in subtle jibes at the world powers, softly calling them imperialist neo-capitalists who were scared of Zambia's space knowledge. Remember the Christian missionary he wanted to send to Mars with the girl and the cats? He had explicitly warned the missionary he must not force Christianity on the people of Mars if they do not want it, a luxury many colonizing nations did not afford their conquered lands. A quiet, pointed commentary. Perhaps unsurprisingly, Encoloso's project never received public or political support. He had written to UNESCO gently asking for a $7 million grant to make his mission a reality, a mere drop in the bucket compared to NASA's $25.4 billion Apollo funding. It's also been reported he asked for $1.9 billion from private foreign sources. But the Ministry of Power, Transport, and Communication was quick to clarify that this request was not made on behalf of the government. In the end, the only funding he quietly got was 10 rupees from a young Indian boy, a testament to pure, innocent belief. Most Zambians did not resonate with the space program and didn't feel it accurately represented the feelings of the nation. In fact, his own astronauts, those brave young hopefuls, gradually deserted him. 2 recruits reportedly went out drinking one night and were never seen again. Another left to join a traveling song and dance group. And Mata, the young space girl, ended up having a child of her own and staying home instead of going to Mars, a gentle return to earthly realities. In hindsight, we can only quietly speculate what Nkoloso's true intentions might have been. Maybe it was a shrewd ruse to make international headlines and get the name of a newly independent country out there. Given Nkoloso's history as a revolutionary, it wouldn't be out of character for him to want to replace the name Northern Rhodesia with Zambia on the world stage. And while he had everyone's attention, he might have subtly thrown in some satire aimed at the superpowers, just for fun, a quiet, clever commentary. Or he might have hoped against all odds that their hard work and determination would impress the right people and actually get Zambians into space, a genuine, if improbable, dream. Or perhaps he was simply trying to make some kids feel like they were part of something big and important, igniting a spark of wonder in young minds. What we do know is that he never let setbacks squander his determination and belief in his vision. Thanks to him, even for a brief moment, Zambia bravely entered the space race against the US and the Soviets, a quiet, inspiring challenge to the established order. This is a vibrant story of one man's audacity, determination, and self-belief. The reality is that not everyone who dreams of making it into space ends up going there. But whether he meant to or not, Nkoloso told the world in his own unique way, "We are here, we are Zambian, and we are free." In a profound sense, he reminded us that those epic, larger-than-life endeavors like reaching for the stars and exploring the vastness of the universe stem from a desire innate in us all. And that in itself makes it a story worth telling, a quiet whisper that echoes through time, long after the laughter and the skepticism have faded. It reminds us that dreams, even the most improbable ones, have a power all their own, a quiet light that illuminates the human spirit.